Välkomna till Esri Sveriges studio där vi sänder direkt här nu i väntan på Esris internationella användarkonferens ifrån Kalifornien. Jag heter Oscar Monell och här har vi också med oss Lars Backhans, VD. Vi har Annika Hermodsson, konsultchef och vi har Håkan Nordlund, CTO. Ja, så här dags när vi är på plats i USA normalt sett så brukar spänningen vara mycket stor. Vi står ett stort antal personer och väntar på att dörrarna ska öppnas så man kan springa fram till sin favoritplats. Lars, hur brukar det kännas när vi är i San Diego?
Ja, för de som inte har varit på någon sån här amerikansk konferensanläggning så är det ju speciellt överhuvudtaget att kliva fram till en byggnad som är kanske 1,5 kilometer lång eller något sånt där. Och sen är det över 30 grader varmt utomhus och sen så går vi in och där är det 15 grader varmt och så har man en fleecetröja med sig för att stå ut. Och sen så vill man rusa in och ta plats bland 17 000 olika GIS-entusiaster från hela världen. Och den spänningen, den stämningen där är helt fantastisk tycker jag.
Det låter helt magiskt. Och Annika, du brukar ju se till att alltid vara längst fram, så nära scenen som det bara är möjligt. Varför?
Det är en sport såklart. Nej, men man vill ju se allting först. Och ju längre fram man sitter, desto snabbare får man ju se det såklart. Det är den liksom klara förklaringen till det hela.
Ja. Och hur många konferenser har du varit på?
Oj, åtskilliga. Första var 2005. Då var Håkan min chef. Och jag blev skickad till USA på den här fantastiska konferensen. Och när man kommer in i den här stora salen, då var det inte 17 000. Vi var kanske 10, 12.
10-11.
Ja, 10-11 kanske. Ja. Men att se alla dessa människor och känna att alla de här, de tycker och har precis samma mål i livet som jag. Med att liksom, och GIS är så fantastiskt. Så det var ståpäls och det får jag nästan nu också. Uh-huh. Och nästan att man faktiskt, det kom en tår.
Ja. Ja, men den här lite magiska, härliga känslan.
Ja.
Och Håkan, du har varit med ett tag på Esri Sverige.
Ja, jag har varit på några konferenser
konferenser. Hur många har du hunnit med?
Ja, jag vet faktiskt inte. Men...
Det här är den 41:a konferensen vi ser fram emot att få se här nu.
Min första var 1993 och då var vi i Palm Springs. Liten anläggning som vi växte ur. Jag tror vi var kanske 5-6 tusen människor. Och sen flyttar man från Palm Springs till San Diego och vi för första gången fick se den här gigantiska byggnaden som Lars nämnde, som man några år senare faktiskt byggde ut så den var dubbelt så stor. Så att den är ju ganska enorm. Så att jag har varit på många konferenser men det är faktiskt lika spännande varje år. För det här är ju en stor grej även för oss esrianer, likväl som alla användare, och se alla nyheter och träffa alla kollegor och alla användare och liknande. Så det är en stor grej. Men sen i och med att jag har varit med några år så har jag ju utvecklat det här med att gå på konferenser. Jag behöver inte sitta längst fram som Annika. Men jag är ruggigt duktig på att hitta ett ställe där jag inte sitter under en fläkt. För det är som Lars sa, det är 15 grader varmt eller 17 en bra dag. Och 30 grader utanför. Så det är ju
stor skillnad.
Det är någonting man lär sig. Någonting man lär sig. Men det är ju faktiskt en av de största händelserna på året. Det absolut.
Ja, men det är förståeligt. Annika, vad är ditt starkaste minne från någon av de konferenser du har varit med på?
Alltså det starkaste är 2016. När vi har Kalmar länsmuseum. När, nu ska vi säga, Nicolas och, nu tappar jag namnet.
Ja, Fredrik.
Fredrik, precis. Kliver upp på denna gigantiska scen och presenterar det jobb de gör med hjälp av drönare och liksom modern GIS-teknik i den arkeologiska utgrävning som man gör då på Öland i Sandbyborg.
Glöm inte Fabel.
Och Fabel fick ju då, och Fabel är ju då en arkeologihund som är tränad på att söka så här riktigt gamla människor eller ben överhuvudtaget. Så att det där var stort.
En stolthet.
Det var jättestort. Och de fick alltså en sån respons av alla som satt i salen så att det var Ja, det var coolt.
Häftigt.
Cool.
Häftigt. Ja. Och Lars, du som kommer någonstans lite utanför GIS-världen från första början. Hur var det för dig första gången när du var i San Diego och blev marinerad med all denna GIS över dig, mer eller mindre?
Ja, alltså jag kom ifrån Microsoft då, som gör väldigt, väldigt stora produktioner, så här eventproduktioner. Och så kom jag till detta GIS eller vad det hette. Och vad är det här nu? Är det 10 år sedan? Och så kom vi in i detta tillsammans med 17-18 000 GISare. Och så var det lika stor produktion. Alltså jag blev jätteimponerad. Och omedelbart förälskad i den här teknologin.
Ja, häftigt. Temat för årets konferens är GIS Creating a Sustainable Future. Och jag vet inte, Lars, kan du berätta lite mer om vad det här temat betyder för dig och för Esri Sverige som företag också?
Ja, för mig personligen är det ju jätteviktigt. Det är väl ingen av oss som kan ha undgått och se hur läget är i världen klimatmässigt. Så, och vi som har barn och allting annat och så känner jag att det är oerhört prioritet. Sen för oss som företag så har vi 2 perspektiv i hållbarhet. Och det ena är hur vi som organisation inom Esri Sverige agerar så hållbart som möjligt. Och där framförallt våra resor försöker vi liksom se till att åka kommunalt, åka tåg och så vidare så mycket som överhuvudtaget är möjligt. Men Esri Sverige är bara ett 100-tal medarbetare och därför har vi ett strategiskt mål att få våra kunder att bli mer hållbara. Och om man bara jämför det som ett exempel, en av våra stora kommunkunder har 17 000 anställda. Om de blir mer hållbara så får det en större påverkan på världen än att bara vi 100 blir mer hållbara. Och så tänker vi runt alla våra kunder faktiskt.
Ja, det är ju jättevärdefullt. Annika, vad tänker du om temat i år?
Jag är lite inne på samma spår som Lars. Men jag tänker också att det finns flera aspekter i det här och det kommer vi höra här under de här dagarna. Just att det är inte bara miljö och klimat utan det är ekonomi och det är social hållbarhet. Och att få med de delarna och vad vi kan liksom jobba med och analysera detta och faktiskt se och titta framåt med historiska data. Det tänker jag liksom att det är väldigt starkt. Det är en viktig del. Att inte bara titta på ett ben i det här utan försöka få in allt.
Få en helhet.
Och göra göra det man kan.
Det finns ju någonting, tycker jag, när man pratar om GIS i sig handlar ju om att vara effektiv. Försöka ta bättre beslut, bättre informerade beslut, använda data och all möjlig vetenskap, allt ifrån sunt förnuft till AI. Och det finns någonting inbyggt i det som jag tycker handlar om hållbarhet. Man behöver inte prata alltid om hållbarhet explicit, just om ämnet hållbarhet så, utan det handlar ju om att försöka vara lite smartare, göra saker mer effektivt, lite enklare, använda mindre energi, mindre bränsle eller vad det nu än gör. Så att för mig finns det här med hållbarhet, det finns liksom inbyggt i det vi håller på med. För det är mycket det handlar om, att försöka vara lite smartare än man var tidigare egentligen.
Ja, och det är ju fantastiskt, alla ni där ute som arbetar med ArcGIS som programvara eller generellt med GIS och vilket otroligt viktigt arbete ni gör kopplat många gånger till just hållbarhet och det tycker vi är väldigt roligt, helt klart. Under den här veckan, ni som är anmälda till konferensen så kommer ni ju kunna kolla på en väldigt stor mängd sessioner. Det är live om man har lust att hålla sig vaken, kalifornisk tid. Då har ni möjlighet att prata direkt med personalen i USA och sen finns det också många on-demand-sessioner som man kan titta på också. Annika, vad innebär det här med att man kan titta live just? Vad ger det för fördelar? Men
det som blir ju en del, det är lite det här att man blir en i hela den här massan. För nu är vi inte 17 000, vi är ju många fler som är med och tittar. Men det innebär ju också att vi kan boka livemöten med våra kollegor i USA. Vi kan också en gång om dagen här i veckan som kommer prata med oss på Esri Sverige. Och vi kan vara med och se liksom samma saker som alla andra ser samtidigt.
Ja, det är jättebra.
Det är ju inte som att träffas fysiskt. Men det är ju så nära det går. I alla fall. Att man kan för varje session avslutas med en QA, en frågesession. Där man kan skicka in sina frågor och få svar på sina frågor. Precis som när man är på plats så kan man sitta kvar och räcka upp handen och ställa alla möjliga smarta eller konstiga frågor. Man får svar på precis allting. Och det är en av de här stora grejerna tycker jag med konferensen. Att dels kan man träffa Esrianerna, det vill säga de som är bakom produkterna. Men man kan ju också träffa sina peers från faktiskt hela världen. Som håller på med samma verksamhetsområde som jag eller jobbar med samma grejer som jag. Och det är ju en stor grej tycker jag. Liksom att det finns ju även här nu digitalt möjligheten att vara med i chattrum eller vara med på QA-sessionerna och även besöka utställningen. Så att säga.
Just det.
Kommer ju att ges möjlighet under veckan. Så att det är väldigt nära. Men det är ju ändå inte riktigt. Det är vi medvetna om. Men man kan ju i alla fall mötas digitalt.
Ja, men det är stort.
Så ska man våga ställa frågor också.
Just det.
Så var inte rädda. Alltså ställ frågor. Det är ingen som kommer att tycka att du kan inte prata ordentlig engelska, vi förstår inte vad du säger. För att de gör sitt allra bästa och ytterst vad de förstår. Även när man hakar sig lite.
Det är ju en väldigt internationell konferens också. Alltså man har verkligen jobbat med att inte bara vara USA utan det är verkligen Europa, Asien, Afrika. Alla är med och det är väldigt härligt på så sätt också.
Det är väldigt få länder som inte är där. Helt man vänder på det faktiskt. Och det är faktiskt lite, jag tycker det är personligt, jag tycker det är jättehäftigt. För man kan aldrig åka på någonting mer internationellt än en Esri-konferens. Därför man träffar folk från hela världen som håller på med saker som man inte visste fanns eller också håller de på med saker som man själv håller på med. Och det är lika roligt att träffa allihop. Faktiskt.
Har du några särskilda intresseområden som du tittar efter?
Ja, det har jag. Så bakgrunden till min nyfikenhet och vad jag ska leta efter är ju att den här programvaran och den här applikationen av teknologin och geografi i form av GIS, den används ju i långt fler sammanhang hos våra kunder men också hos nya kunder upptäcker vi ett intresse för det här. Och vad jag kommer titta efter det är en ny teknologi som kan kugga i den generella digitaliseringen, den tsunami av digitalisering som sker både på privata företag och inom offentlig sektor. Där vi har mycket mer dialog idag med digitaliseringsdirektörer och CDOer och så vidare än vi hade bara för 5 år sedan. Så jag kommer titta efter sådana tekniska nyheter, det som kuggar i den generella digitaliseringsvågen.
Kan man som kund i Sverige få tillgång till din kunskap efter detta på något sätt?
Absolut, det är det roligaste jag vet. Så glöm inte bort det, bjud in mig till möten. Jag tycker det är jätteskoj.
Ja, vad härligt.
Ja.
Jag vet ju det.
Ja.
Och Annika, vad tittar du efter?
Jag gillar ju fakta och forskning. Tycker jag är jättespännande. Så att det går något som heter Esri Science Symposium. Som hölls av väldigt kompetenta personer. Och där kommer man prata om biologisk mångfald, hållbarhet, klimat. Så vidare. Så har man möjlighet att lyssna in på det där så skulle jag säga att det är ett sånt här tips. Sen tycker jag det är jätteintressant att höra vad våra partners gör med vår teknik. För det visar lite för vi tänker mycket men vi kan inte tänka allt. Och det kan ge oss liksom en input till här är något smart. Det här kommer vara användbart för många av våra användare. Och då kan vi koppla ihop oss med dem eller så tar vi våra kunder och kopplar ihop dem med medarbetare.
Det just det med partners och startups är också en stor del av utställningen som brukar vara rätt häftig att se. För det finns mycket smarta människor där ute som gör innovativa saker som är jätteroligt att titta på.
Och det är ju särskilt spännande nu med ArcGIS Platform, tänker jag också. Just möjligheten för kanske startups att få enkel tillgång till vår teknologi. Det
är ju en ny möjlighet för en ny kategori utvecklare egentligen, som jag tror vi kommer att se mer av under året här. Vi kommer att få se mycket av det på konferensen också. Och det tror jag kommer att ge saker som faktiskt ingen har tänkt på. Nej. Och det är det som är lite roligt att se. När det är nya saker som kluriga saker som ingen har gjort förut. Men som kanske egentligen är ganska enkla. Men det gör stor påverkan. Det är sånt som är kul att se faktiskt.
Något mer du kommer kolla på, Håkan, särskilt?
Jag försöker ju täcka... konferensen är så otroligt bred. Och det är jättesvårt att täcka in allt. Men jag försöker göra en så bred bild som möjligt av allt nytt som kommer i plattformen. Men sen försöker jag också, när vi är där på plats, så brukar jag också försöka lyssna på, när det är den riktiga konferensen, då brukar jag försöka lyssna på användarpresentationer som gör ämnespresentationer om det jobb de har gjort och det resultat de får fram och hur det påverkar deras omgivning eller det företag de jobbar för. Det tycker jag är jätteintressant. Men det är som sagt en väldigt, väldigt bred konferens. Och det råd jag brukar ge till de som är med oss när vi är på plats i San Diego, det är att man verkligen sätter sig ner innan konferensen och försöker dela upp konferensen på flera huvuden eller flera medarbetare. För man kan inte täcka in allt. Och sen försöka få en så bred bild av allt som finns. Och sen samlas man efter konferensens slut varje dag, sätter sig ner och jämför anteckningar och sessioner och så här. Och verkligen försöker samla in det som man får med sig på konferensen. För själv kan man aldrig, oavsett om man försöker liksom ställa om klockan som några av våra medarbetare gör och gå upp mitt på dagen och sitta hela natten nu. Så man kan ju faktiskt inte täcka in allt, utan man måste dela det med sina kollegor.
För hur många sessioner är det som sänds live samtidigt? Det är ju ett rätt stort antal.
Ja, jag har faktiskt ingen aktuell siffra. Jag har bara sett att det är väldigt mycket. Ja. Och det är ju ett digert program, även fast vi nu kör digitalt. Så det är jättemycket sessioner.
Men fantastisk möjlighet just för att det är digitalt, det är ju att ni har ju tillgång till alla sessioner i efterhand. Året ut, mig veterligen i alla fall. Och det är ju en fantastisk möjlighet, om man inte orkar titta på alla just nu under sommaren, att ta det där lite pö om pö under hösten. Så det är ju väldigt smidigt.
Men vad tycker du ska bli spännande att titta på då, Oscar?
Men jag är väldigt förtjust i 3D-GIS och allt man kan göra med det. ArcGIS Urban. Där har vi ju vår partner S-Group Solutions som hjälper våra kommuner i Sverige att göra fantastiskt spännande tillämpningar därigenom. Jag tycker det är spännande med vad som händer inom arkitektur och den branschen som representeras av våra teknikkonsulter bland annat. Och all den innovation som sker i partnerskapet med Autodesk. Så att ja, det är några höjdpunkter jag kommer leta efter, helt klart.
Jag har en till som jag kom på. Är det okej?
Ja, självklart.
Ja. Vi snackade lite grann om det här, Håkan och jag, för ett par månader sedan. När Esri har köpt ett företag från Tyskland. N-Frames. Produkt som heter Shore. Och den där produkten tar... jag vet inte vad det här kommer heta när det lanseras nu. Det är spännande. ArcGIS Reality eller Reality Capture eller någonting i den stilen. Och det är teknologi för att ta ett massivt antal bilder som kommer från flygplan eller från drönare och annat och foga ihop det här till en sann tredimensionell modell. Och jag menar då att det är en sann tredimensionell modell och inte bara ett pixelmoln så att säga, inte bara en tredimensionellt foto i någon mening, utan det blir en sann 3D-modell. Och sen så om man drar det lite grann långt framåt i tiden och så tänker jag, en gång i tiden så mätte man in verkligheten med måttband och alla saker och sen så var man tvungen att vara nästan en konstnär och målade ihop en karta och den blev 2D. Och egentligen har vi bara digitaliserat printarkartor i digitala kartor egentligen. Och sen har vi fått lite 3D och såna här saker. Men jag tänker att vi ser början på att GIS blir en tredimensionell representation, en tredimensionell modell av verkligheten snarare än en karta.
En tredimensionell äkta digital tvilling.
Ja, att egentligen. Det blir det. Så här, och då ändras ju allting på något sätt. Ja. När vi tänker att från datafångst, liksom hela produktionslinan till att vi konsumerar den här informationen 3D och inte bara VR-glasögon utan liksom att allt vårt enterprise-data hamnar i 3D. Då blir GIS inte bara den geografiska komponenten liksom, som bidrar in i annat utan det blir det canvas på vilket verkligheten modelleras upp. Och det här kommer ju ta tid så här, men jag tänker att det här är nya GIS om 5 år eller 10 år, jag vet inte hur lång tid det är. Jag tänker alltid fel när det gäller innovation.
Ja, men en fantastiskt bra framtidsspaning tänker jag. Jag tror det är helt relevant.
Jag är helt övertygad om att vi kommer få höra mer om det där under de här kommande dagarna.
Ja, men så spana på det liksom, ni som sitter här. Det här tror jag är framtiden.
Vi närmar oss strax Jacks plenary-session då i Kalifornien och ni kan stanna kvar i den här streamen för att vi kommer gå över direkt till den sändningen. Men sen så kommer vi tillbaka klockan 21 ungefär ikväll beroende på hur lång tid Jack tar på sig. Man vet aldrig riktigt som ni vet. Och då kommer vi prata lite om det vi har sett under den här starten på användarkonferensen. Vi kommer också prata lite mera då om våra svenska användardagar, om vad det innebär när vi träffas igen i oktober nu i Sverige. Och också lite vad du kan uppleva mer på den plattform som finns kopplat till UC. Vad du hittar för sessioner, vad du hittar för möjligheter att träffa partners och Esri-personal. Så att det är riktigt spännande och så. Men jag tänker så här precis innan det startar, då brukar man alltid ha lite härlig musik i högtalarna och det blir den här härliga känslan tycker jag. När man sitter tillsammans i det här folkhavet. Nästa år måtte vi få komma dit.
Ja, gud ja. Jag saknar... Jag kommer ihåg när jag började på Esri, då sa min dåvarande chef, kom ihåg att vi begär av dig. Du måste ställa in dig på att du måste åka till södra Kalifornien en gång per år. Ja, jag tänkte det är rätt enkelt då.
kan väl stå ut med
det. Det är inget problem med. Ja,
men det är väl rätt härligt på så sätt. Men vad känner ni mer liksom när man sitter där de här sista minuterna innan? Vad är känslan? Spänning.
Ja, spänning och förväntan. Förväntan. Och sen mitt i allt det här så är man ju faktiskt lite imponerad av den här produktionen just som de gör, som är så oerhört professionell.
Ja, men, och det är ju verkligen det här. Det är ju som julafton för oss som gillar GIS någonstans. Ja, fantastiskt härligt att se. Hörrni, vi ses igen klockan 21. Nu kör vi igång ifrån USA. Ha det så kul!
Done, loved, took place on this drifting, spinning ball that's our home. It's where we learned to provide, nurture, protect, thrive. And yet,
wildfires are scorching the West Coast, leaving behind a path of death and destruction.
Inches of rain this morning.
The waters keep rising, and according to the National Weather Service,
our very success now threatens our future. Today, our greatest challenge is to learn how to grow while sustaining what sustains us. Your understanding, your science, your work are the solution. You have the power to see patterns and relationships and show us how everything and everyone are connected. You have the power to transform how we produce and consume, build and maintain, unite and strengthen, heal and nurture. You can help us see that we can no longer live apart from nature, but must live as part of it. Today, geography matters more than ever. The geographic approach, your work, and the billions of maps you make are essential for creating a more sustainable future.
Good morning, everybody. My name is Jack Dangermonds, and it's my great pleasure to welcome all of you from around the world to the, 2021 International Esri Users Conference. The purpose of this meeting is quite simple. It's to help you in your career, for us to share the technology that we're advancing, but also an opportunity for you to share the work that you're doing and give us feedback. It's about understanding and learning and inspiring each other to take on the great challenges that our world is facing today. This year, in addition to all of the activities that are underway, we're also going to be focusing on creating a more sustainable future for our planet. Before we go further in my presentation, I'd like to say a few words about who you are. This year, we're joined at this conference with over 50,000 GIS professionals from about 130 countries. And you have many different backgrounds. You're special people in the sense that you're GIS users, but you're also from different fields. Thousands of teachers, thousands of science people, people working in government and in business. Your backgrounds are different, your organizations are different, yet you've come together to create a kind of global geographic information system community. The work that you are doing is, from my perspective, just extraordinary. For the last month, you've been sending me maps and examples of your work, and you sent thousands. And by the way, I wanted to say thank you very much. I've been combing through it and studying it. I'm almost overwhelmed by the breadth and the magnitude of your work, addressing virtually every big issue that our world is facing, from energy to environment, to climate change, to modernizing cities, and so on. Each year, at the beginning of this conference, we pick just a few of those and show them and showcase them, and I'm going to do that right now. Here's some examples of your work in environmental monitoring and assessment. And wow, I'm just saying, there's hundreds of submissions on this year's presentation, but look at the one in the upper left, the good work of the E.O. Wilson Biodiversity Foundation, mapping biodiversity for the planet. Some of you are working on looking at the footprint of humans, like up in Canada in Ottawa, and others are monitoring things like sea ice, they're tracking fish movements, they're looking at water quality, and thousands of other activities related. These examples show your work in natural resource management, ranging from sustainable farming in Brazil to looking for suitable farming in the Navajo Nation. In forestry, almost every modern forest organization uses GIS in one way or the other. But I'm charmed by the little slide in the lower right showing field-based forestry management activities for small foresters in Germany. Lots of work in conservation. I'm very pleased to say that this is some of the most important work that we must do. Planning, managing, understanding. In the center, we see the analysis, the science analysis of using GIS to manage land information, land records. Let's call them parcels. And these are kind of a foundation, in my view, for so much of our civil society. But it's not just managing the boundaries, doing the system of record that is shown here. It's the application of those records, integrating it with other layers like soils and floodplains to do more rational assessments, property assessments. And look at the one on the far right. This was done by the Dutch cadastre working in Colombia to have a fit-for-purpose configuration of the collector technology for field surveying of cadastral data. Many of you are working in urban design and planning, creating a future in our cities. And here, again, I'm so anxious to share these with you. In the far right, we see Berlin and Brandenburg region really working on creating a sustainable urban footprint. And this is some of the best work going on in the world, frankly. Others are updating urban plans like this, visualizing what's going on, creating new patterns of development, doing it in such a way that it is sustainable and administratively correct. GIS is continuing to evolve, and over the years I've watched it in this evolution. One of the big steps that has been made in the last few years is the movement into buildings and facilities. Its integration with BIM has meant that a whole new class of applications are emerging, from space management and fighting fires and indoor response. For example, this great work in Kuwait by the fire department. And look at the upper right-hand corner. This is CERN. CERN is the large European research center where the nuclear accelerator lives. And they have actually moved to a state of managing all their workspaces on the entire campus using GIS as a framework. GIS originated in many places, and one of them was in transportation with advanced modeling, trying to predict movement of people. In the lower right, you'll see in Jakarta the application of origin-destination modeling to predict ridership in buses and other vehicles. And in the far left, you'll see the application of GIS to optimize bus routes and also pick the right locations using operations research tools for stops. Many of you have traveled through the San Francisco airport before, and that entire complex is now managed with GIS, including all the rooms and walking times from gate to gate and so on. But speaking about time, the upper left-hand slide is interesting because it shows real-time traffic monitoring. Increasingly, this is a pattern going on in various regional and national agencies showing real-time geography. Engineering and public works management organizations are embracing the power of GIS to do their applications at many scales. I'd like to draw here your attention to the map in the center by Tetra Tech, which is a pipeline, showing a pipeline across Pennsylvania being constructed. What they applied is the web map pattern, and associated with those web maps, all the different construction status activities during construction. It was kind of a living construction manifest. In the lower left, I like this green map because it's showing the targeting of where infrastructure investments should be made. This is a very relevant topic for all of us these days. And again, one of my favorites in this collection is up in the upper right in Switzerland, looking underneath the ground at pipelines, not the exact location, but the approximate location, which is helping excavate and understand the grid underground. Water and wastewater management agencies around the world are using GIS for asset management, things like being able to support service orders or manage inspections. Look at the one on the left. It's looking at the analytics. It's making a map showing age of the network, analyzing, again, where investments should be made. But here, my favorite is up in the upper right. It's showing not a real time, but looking over the last quarter at sewer conditions and how they changed almost at a glance. In other words, summarizing all of the asset information and its management. Utility energies, electricity and gas, are likewise using GIS for traditional applications like asset management and vegetation management, and increasingly for outage management, like this interesting map in the center showing the outage of the Colonial Pipeline gas network in the southeast as a result of the cyber terrorism activities. But in almost every utility that I'm talking with these days, they're moving over to renewable energy. They're hunting for the right locations for solar and for wind production and applying GIS to manage their farms in a whole new way. Similarly, in telecommunications, both traditional networks, wireline or 4G, is being managed extensively with GIS, but also the next generation of telecommunication, 5G, like this beautiful example in Sydney showing siting of tower to support using viewshed pick the right location for these towers. And in Albuquerque, they're doing network planning. And our national government here in the US is using it to assess and model the coverage of broadband for the entire country. This is a very important topic because it identifies those areas where we have the potential of a digital divide, those populations that are being left behind because they're not connected to the web with powerful enough network. Our cities, our countries, our nation, our world is safer because of GIS. In the law enforcement areas, they are looking at past historic crime rates to see pattern and allocate resources accordingly. They're also increasingly looking at real-time information, doing crime monitoring. They're looking at everything from school threats in local geographies all the way to monitoring our global security risk. And EMS organizations and fire organizations are not only picking the right locations for their facilities, like based on drive times, but they're also addressing major and significant issues like the opioid crisis here in the United States, being able to respond more effectively. In the field of disaster preparedness and response, likewise, GIS has had a long history. These examples show some of the modern stuff that's going on. I'm fond of this one in the Congo done by Kokusai Kogyo, looking at ground deformation near a volcano. But whether it's fire real-time or fire assessments of risk or doing damage assessments and in flooding and in severe weather, GIS is playing a very significant and major force. Now, the lower right shows, again, Kokusai Kogyo in Japan simulating the Fukushima earthquake that had happened a few years ago. And in this simulation, they're developing methods to be able to apply very quickly what might happen in other places in Japan and around the world. In 2020, the US Census carried out their centennial count of population. And GIS was central for this, not simply in making the maps, which are shown here, but also in actually structuring and running the census. It's based on geography, of course. And they were able to maintain with dashboards the completeness of their count as they carried it out. Now that the census is done, America is doing redistricting, which are political redistricts for congressional members. And GIS is again playing a significant role. I'll call your attention here to the map on the far right and the lower, which is illustrating population migration to Libya from across Africa. Libya is kind of a gateway into Europe for migrants, and these maps are quite extraordinary. Your work in social equity, particularly in the last year, is striking. You are studying the lingering effects of redlining, or de facto redlining still existing in Detroit. You're looking at accessibility, for example, accessibility to health facilities, or the relationship between poverty and access to legal resources, or in your planning work, looking at trails and equity planning and park accessibility relative to equity, creating understanding and creating what I see in the future, a more equitably and balanced population. COVID has affected nearly all of us. And last week, we passed this mark of 4 million people on the planet have died as a result of this horrible disease. Your work has contributed here because it's shown the world what's going on. The great work by Johns Hopkins University keeps track even today and has made over 2 trillion maps. Not only are we better informed of what the status is, but as the interesting visualization in the center shows, we've been able to look at patterns. This is showing the dynamics of what happened in Central Europe, or Europe, during the winter months during the disease. And your applications in site selection for vaccination, or return to office management, or even look at the interesting map in Liberia where they mapped in great detail every case and set up quarantine zones to shut the pandemic down, and it worked. GIS continues to grow and be hugely beneficial in both business analysis and economic development. These examples show it. Optimizing delivery routes, cutting carbon. Picking the right locations to avoid multi-hazard insurance, like in Japan. Picking the right sites, picking the right territories. All of these are very powerful, not just in business, but increasingly being used in government to target economic development sectors of various types. Imagery and remote sensing of many different types is increasingly infiltrating, impacting, benefiting the GIS workflows that many of you do, whether it's vegetation health from recently collected drone imagery or forest inventories at a massive scale, like at the U.S. Forest Service. Over on the far right, you'll notice this intriguing map to look into the ground and understand pipe deficiency. And another one like that is the satellite-derived bathymetry map. And then, I like this slide very much because your work is showing a complete gamut, including surveillance of illegal fishing to protect the Galapagos, for example, and modeling snow depth and runoff. These are hugely beneficial dimensions of remote sensing that are affecting GIS and geography in general. These maps show a collection of just beautiful cartography. And I picked these myself. I just found them very interesting. The warming of the Arctic by the Woodville Climate Research Center, or these maps of Mars and the terrain surfaces. And look at this interesting one about picking suitable landing sites for the Mars lander. We'll come back to that later in this session with a presentation from JPL. The hiking map atlas I'm very fond of. This company in Austria has been in existence for 250 years, and they now have a completely automated GIS-based atlas generation activity. And over in the far left, we can look at a zoning map that was made for colorblind populations. It's an interesting palette that is available now that we can apply in various sorts of settings. All of these maps that I've been showing you, these maps, but also all of the work that I've shared in the last few minutes, have interesting stories associated with it. I absolutely sense that I grew as I read these stories. I understand better the kind of footprint, the magnitude of the work that you are up to. Each year, we select out of our 350,000 customers around the world, a small group of people, less than 150, to receive what we call a Special Achievement in GIS Award, or a SAG Award. These are the ones that were selected this year in the United States, and these are the ones that were selected around the world. These organizations distinguish themselves by really doing fantastic things. They organized all the data. They built the right applications. They organized the right institutional settings for their work. And normally, I would have them all stand up if we were all together in an audience and we could acknowledge them in the right way. I won't be able to do that obviously today, but I do want to send a warm message to all of you in these organizations, how very proud I am of your work, but also just you should feel very proud and special for doing the kinds of things you're doing. Each year, we also select several of our users for very distinguished acknowledgement. The first one this year is the Making a Difference Award, which is going to Nespresso. This is a division of Nestle. And this organization is amazing because it's working with over 140,000 farmers, small farmers, scattered through 20 countries, helping them in sustainability farming. They have over 400 staff working with these farmers. Well, I don't want to speak all day about them, but I'm very, very excited about them. I'd just like to share this short video and then introduce you to Jan DePietro.
Que se despierten todas las mañanas tomándose el mejor café del mundo y que estén totalmente tranquilos de que ese café proviene de un equipo atrás de cafeteros, de un proyecto de agrónomos que están en pro de la calidad, pero siendo muy responsables siempre con las comunidades, con las familias, con los trabajadores, con el agua, con la tierra, con los árboles. Queremos apostarle a reducir la huella de carbono que se puede producir por una taza de Nespresso mantener la calidad del agua, tratar de descontaminar el máximo lo que se puede y cuidar los suelos, ¿sí? Y la estructura ecológica principal de la región cafetera.
La aplicación de siembra en el modelo agroforestal, porque le está garantizando al caficultor que va a tener una sombra adecuada para el proceso de calidad de su propio café.
Somos responsables de que la cuenca siga floreciendo agua, siga progresando, siga produciendo café, el café que ustedes se toman, el café Nespresso AAA.
Dear Jack, dear GIS community, greetings from Switzerland. I'm Jan, and on behalf of Nespresso and all the teams involved, I want to thank you for this incredible award. Innovation and sustainability are deeply anchored in Nespresso DNA. So it's no wonder that we started to use ArcGIS to support our journey towards positive impact. We use ArcGIS in many fields of work within the Nespresso AAA program, climate actions such as agroforestry, and more recently for COVID-19 response in support of partners and farmers. Climate change is clearly the greatest threat of the 21st century, and coffee is no exception. We will only be able to meet the challenge with a clear action plan and the efficient technologies to bring it to life.
We are really pleased to receive this award, recognizing our work and vision on sustainability. Of course, we could not be at this level without strong partnership and specifically Esri along the way. We are currently finalizing our sustainability strategy and vision for 2030. And as we will address and continue to address the key biggest challenges on sustainability, such as climate change, farmers' livelihood, circularity, or carbon neutrality, digitalization and geospatial analysis in particular will be key for us in the implementation of this strategy. We know many challenges are ahead of us. Businesses must be part of the solution, and Nespresso will continue to focus on being a force for good, to preserve our planet and to improve the livelihood of our farmers and the communities. Thank you again for this reward, and take care.
It is extraordinary work, and I think all of you would agree. This kind of footprint is giving us a model for the entire world about working diligently at creating a more sustainable planet. Our second special award this year is being given to Logic. This is the Louisville Jefferson County Information Consortium. This has been going on for 35 years. It was started in part by Kurt Bynum, who is still there. He's still the GIS manager. They have 1,300 different databases that they maintain. They have thousands of applications that support water and sewer and urban planning and law enforcement and citizen engagement. It's a real enterprise system with the city and the county and lots of volunteers. Accepting this year's prize is actually the Mayor Fisher, Greg Fisher from the city of Louisville. So Greg.
Hello, everybody. Louisville prides itself as a city where innovation is driven by community collaboration. Our Logic GIS represents a successful 30-year partnership that has changed how we conduct our community's business and serve and inform the residents of our great city. Logic is our shared warehouse of all manner of spatial data about our community. I want to thank our Louisville Metro government team members who work directly with Logic, the Jefferson County Property Valuation Administrator, the Louisville Water Company, and the Metropolitan Sewer District for enthusiastically backing the idea of collaboration to help our community. I also want to thank Kurt Bynum, Director of Logic, and his team for delivering on this critical resource. Most recently, we used Logic to monitor and report the impacts of the COVID-19 pandemic in our community. Logic also has been a valuable asset in our important work of advancing racial equity and economic development through the creation of a large and growing gallery of interactive web maps dashboards, and story maps to inform our citizens and share our wealth of spatial information about our community. Our goal has always been for Logic to serve as a model for GIS collaboration, organization, governance, funding, and resource sharing. So on behalf of all of our partners, professional GIS staff, and our growing user community, we are proud to accept this Enterprise GIS Award. Great job, everybody. Thank you.
Well, thank you, Mr. Mayor. That's great. And the little short summary gives you some glimpse of just how, I mean, the reason why I picked this organization. It's just, it's a geospatially literate community. Actually, my award, it's the President's Award. And this year we're giving it to the University of Michigan. University of Michigan is a very large, over 50,000 student campus. Actually, it has 3 campuses. And they're being given this award for a whole bunch of reasons. Peter Koop, who is the lead GIS person on campus, has brought GIS to the entire campus. It's opened up the eyes of many departments. And they're doing not only simple GIS access to every student, but they're also going deep in some of the best work that I've ever seen. I'm particularly fond of Peter because not only is he a beacon of how to do university-wide enterprise implementation, but he also shares. I mean, he criticizes us, makes us better, but he also shares to educators around the world about how to set this up, how to make this thing come alive. So, Peter, could you say a couple words for us, please?
Thank you, Jack. It is truly an honor to have our work geo-enabling our university recognized with the President's Award. Over 7,000 people use GIS across our institution, and that community continues to grow year over year at an ever-accelerating pace. Our goal to empower everyone with everything GIS began with the introduction of ArcGIS Online. The software as a service model enabled us to greatly expand the reach of GIS beyond the traditional desktop server world of the past, with minimal effort and to all disciplines. Today, most units on campus have some faculty or staff using GIS, while nearly all degree programs include students who have used some form of GIS during their time at the U. On behalf of the University of Michigan and my fellow GIS advocates joining me today, thank you again, Jack, for honoring our work with your award.
Thank you again, Peter. It's just amazing. And I want to say, all of us appreciate the great work and leadership that you're providing. I'd next like to move on to the theme of this year's conference, GIS, Creating a Sustainable Future. This is a strong vision, and part of the vision was inspired by a recent book that I read by Mario Palma, who is one of the founders of INEGI, which is the large statistical and science and mapping organizations in Mexico. He said the following in his book: lack of understanding of our reality is one of the greatest risks our society is facing. And I think all of us in the GIS community, all of us in the world community can understand this. He also later said in his book, our future depends upon creating and applying that understanding. And these were the beacons that started INEGI, but they're also, for me, they speak to me, these words speak to me, because they really are a purposeful way of describing our work. Creating and applying understanding. Our world is a complex and highly interdependent ecosystem that's rapidly changing and evolving. The world we live in is actually not well known. It's fragile. It's rich in biodiversity, which is disappearing at an alarming rate. It's also increasingly dominated by human activities. And geologists are beginning to call this the Anthropocene epoch, that epoch where humans absolutely dominate the life and the history, the life, the future of our world. Today, our world is being challenged because us as humans are living recklessly and unsustainably. And this is threatening our future. Human-induced climate changes and overpopulation are resulting in interconnected patterns of change, steep declines in biodiversity, and many other factors. We read about them, scientists tell us about them almost every day. Clearly for me, personally for me, it speaks that we collectively, we as a general human population, but also we as GIS users, are collectively responsible for its future. And it could go many ways. Creating a sustainable future, which I believe is possible, will require that we dramatically change our priorities. I believe in this strongly about making a major commitment to life and our future. And we must act now in order to achieve this. There are many things to do, like restoring nature, improving business efficiencies, reducing pollution, consuming less, implementing sustainable land use patterns, and many, many more. Applying our best science and our best technology and our best creative thinking will clearly be necessary. And I can't help but think and know that geographic thinking is going to be essential in this. Sustainability requires that we see the world as one single ecosystem. Geography, the science of our world, provides the science and the language to be able to do this. It helps us organize and integrate all the factors, environmental factors like biodiversity and ecosystem services, and integrate them with economic systems, spatially, seeing their connections. It allows us to integrate them with social factors, and the maps that you shared, that I shared about your work a few minutes ago, are the evidence of this. It not only organizes and integrates all the factors, it also illuminates patterns and relationships and helps us discover things. It provides us a framework for understanding and applying our knowledge. I like to call this the geographic approach. The geographic approach is a way of thinking and problem solving that integrates geographic science and information into how we understand and manage our planet. And Mario Palma would clearly understand that. It's a holistic approach. It brings sciences together. It's integrated. It supports and is enriched by spatial understanding, and it is also collaborative. The idea is supporting multiple objective solution creating, inclusive and multidisciplinary in its nature. And the great hope, the great vision, is that this will impact virtually every sector of our society going forward. This approach integrates and supports powerful methodologies familiar to many of you here in the audience. Geoanalytics, creating insights and understanding. Geovisualization, a language like through maps and visualization for communicating the content of our world and the context of our world. Geodesign, designing sustainable and inclusive futures. Geocollaboration, engaging all the stakeholders, and geoaccounting, being able to account for all the factors. Setting up measures that are not just economic driven, but are driven in a mixed way, balanced way. And this geoscience and understanding can support our future. It can support our planning, our decision making, our engineering, our operations, how we manage our individual organizations, and how we manage the world. These are all critical. And I appreciate the good work that you are already doing. Clearly, GIS enables the geographic approach, the very tools that you use for measuring and visualizing and analyzing and making predictions, doing planning, making decision makings. All that work that you do is a kind of framework and a process for applying geographic knowledge, this integrative knowledge widely. And as I already said, you're already doing this. You are applying the geographic approach and creating so many solutions for a sustainable future. You are protecting biodiversity. You are reducing the use of precious resources. You're optimizing logistics. You are managing sustainable agriculture and forests. The examples from, for example, the great coffee growers are proof of this. However, clearly we need to scale up our collective efforts exponentially. GIS technology can help us. It's not the only thing, but it can help us. And it is advancing rapidly. It's integrating many new innovations, helping us reach this kind of scale. This will be essential. Things like cloud computing, advanced analytics, the integration of imagery and remote sensing, interactive mapping, 3D visualization. Remote sensing is just a piece of it, but it's a major and significant part. Opening up access to this through the multitude of apps. All of this will help us scale up our collective efforts. GIS is also increasingly becoming interconnected, creating what I like to refer to as geospatial infrastructure. We're connecting our systems, and this in turn is helping us collaborate. It's helping us share. It's transforming workflows and decision-making at many scales. Geospatial infrastructure actually is, and I'm seeing this live in different organizations like Louisville, for example, it's actually transforming organizations. It's creating a whole new kind of intelligent infrastructure, not just digital infrastructure, not just water infrastructure, sewer infrastructure, or road infrastructure. It's creating a new kind of infrastructure for organizing and making distributed data that we collect available. As a basis for this, it's shared geospatial services organized through portals for discovery and access by apps that now support all types of users. This is an exciting time because this infrastructure, and I'm watching it closely, and so are you, is expanding really quickly. It's supporting not only local applications, shared information and so on, but also global applications with millions of users and tens of millions of shared data sets and services that are being made available in this way. It's making billions of maps every day. And these billions of maps are reaching billions of people. They're changing how they think. It's creating a whole new kind of global information system. You've heard me before talk about a nervous system for our planet. My sense is this infrastructure is creating a nervous system for sustainability. I'd like to talk about some of the details of this nervous system. First, geospatial infrastructure is integrating all kinds of data. It can now integrate all types of tabular data and map data and imagery data. It can integrate real-time data and abstract them into these web maps and layers and scenes that we're finding so dramatically useful, so that apps of many types can use them. Geospatial infrastructure delivers powerful apps, not just for GIS users in desktops and so on, but these apps are going to scale with massive mobile deployments for collecting data and also disseminating data. And also the pervasiveness of web apps is just unbelievable. Literally trillions of maps being looked at around the world. And my big hope is that this will continue to expand as it has in the last couple of years, enveloping and bringing us together as a society. Some more details. This geospatial environment, these geospatial capabilities are becoming embedded in other large IT enterprise systems. Our colleagues in other companies like Microsoft and IBM and Salesforce and Amazon and on, Autodesk, are putting maps and geospatial information into their apps. And that is, in turn, changing how they do engineering and CRM. And yeah, well, you can just look at it. It's really integrating geospatial thinking and geographic thinking into the apps that non-GIS professionals use across the organizations. And complementing this is the enrichment that's happening as a result of advanced GIS analytics. This is allowing us to see new things, create new insights with predictive modeling or the ability to analyze spatial temporal information together, the ingestion of real-time information, and the simple tools to be able to interactively do visual spatial analytics. These are powerful. And then enriching it further is GeoAI, machine learning, and so on. And the ability now to store imagery in the cloud and perform advanced raster analytics. And finally, big data, the ability to integrate and pull on and create understanding from these massive data sets. I want to talk about a couple of these. Big data integration is going to open our eyes. It's going to let us see new things, relationships we never understood before. The ability to access these massive data collections from transactional systems and imagery and link them to the very same tools that you are using will create new forms of understanding. Imagery and remote sensing is one category of that big data, and it is enriching GIS, as we already saw in the examples that you shared, all the way from simple image-based maps for thematic underlays to oriented imagery, integration of motion imagery, dynamic image processing, point cloud visualization, and as I mentioned before, GeoAI and machine learning, which is allowing us to pull off the image feature information that enriches our GIS. All of this imagery data is increasingly being used in raster analytics and modeling. And increasingly that's being put into the cloud. We'll talk more about that together. Bringing all of these sources of data together and being able to integrate into your work these timely information sets. Well, I have been talking a bit about the nature of the geospatial infrastructure. I'd like to shift for a couple of minutes to hearing from the U.S. Forest Service. Actually, the U.S. Forest Service has been my customer now for 51 years. It's quite extraordinary that they are now, the chief of the Forest Service is going to share with us some of the great work they are doing at scale, bringing a lot of this information together. So, Vicki Christensen, can you start it off for us, please?
The mission of the United States Forest Service is to sustain the health, diversity, and productivity of the nation's forests and grasslands for the benefit of future and current generations. And the purpose of our stewardship work is supporting nature in sustaining life. And to advance our mission and to serve our purpose, we balance the short-term and the long-term needs of people and nature by working collaboratively with communities and partners, by delivering world-class science, technology, and land management, and by providing access and resources and experiences that promote economic, ecological, and social vitality, and by connecting people to the land and to one another. And one of our key values is grounding our decision-making in authoritative science, inasmuch as the agency and other forest managers across the country are facing difficult choices and opportunities about carbon management, addressing environmental justice, and supporting a resurgent economy. Our research and development branch is actively supplying essential data, information, and knowledge to inform decision makers and the public. You know, Congress charged our Forest Inventory and Analysis Program, FIA, to improve our use and integration of advanced remote sensing technologies. And to fulfill this request, our R&D unit and our CIO and Esri are engaged in a critical partnership in developing the next generation of information products designed to inform today and tomorrow's policy and management decisions regarding our nation's forests. So let me pass this over to our great FIA team, who will share the details of their work and recent successes.
Hi, I'm Hobie Perry, and I'm joined today by my colleagues Ty Wilson and Chris Oswald. FIA collects measurements of trees and other attributes on a network of over 350,000 plots. Each plot has a footprint a little smaller than a football field. We have plots from Palau to the Virgin Islands, and let's take a look at Wisconsin. You'll see we sample national forests. We sample state forest lands. We sample tribal lands. We sample lands managed by county and local government. And all those plots not in any colored polygon are the observations we collect on private lands. We monitor all of America's forests to facilitate shared landscape scale stewardship. Now we know we can't measure everything. The Southern Appalachians highlight the incredible variation in land use that occurs between the plot observations. We also know that remotely sensed imagery alone can't match the richness of data captured by boots on the ground. So we created a big map our cloud computing solution optimized and tuned to leverage the parallelization and mass storage required for raster processing at scale. We fused thousands of Landsat scenes with hundreds of thousands of plots, ultimately processing tens of trillions of pixels in the cloud, all in a matter of days. This map of forest type groups is just one example of the authoritative, science-based output we are now publishing. Layers like this help us understand the variation and complexity of the forest resource. For example, we know that different forest types, shown here in Northern California, have different sensitivities and responses to wildland fire. Naturally, we make this content available to you, along with our agency colleagues. We're publishing it in the Forest Service ArcGIS Online organization, the Living Atlas, and open data portals. We support planning and decision-making with a seamless workflow, from data generation to discovery, consumption, and application. Another example is this map of predominant major forest carbon pools. Management actions will differ for landscapes dominated by live biomass in green, a dead biomass in purple, or soil carbon in brown. And maps like these give us the ability to populate spatially explicit tools that may be integrated into conservation planning to support carbon management, wildlife stewardship, watershed restoration, and other environmental services. But I'm getting ahead of myself because I suspect you're interested in how this actually happens. So let me introduce Ty to explain more.
I'm going to take you on a quick tour highlighting some of the science behind our Big Map project. In order to tackle complex, multidimensional raster analysis problems, we leveraged the versatility of ArcGIS with Python and its numerous machine learning packages to build custom algorithms modeling the relationship between satellite imagery and forest characteristics we measure. By tracking changes over time for each pixel in a satellite image, we can monitor seasonality in vegetation. This provides information about the amount of live vegetation, timing of bud break and leaf fall, and length of the growing season. From this, we can infer the presence of different types of forest, composition of tree species, and overall forest structure. One of the techniques used for analyzing these time series is harmonic regression. It quantifies the shape of a profile as a Fourier series, allowing us to characterize not only the average vegetation condition, but also how those conditions change over the course of the year. These coefficients describing seasonal changes in vegetation, along with auxiliary data like climate and topography, are powerful features for modeling forests. Through ecological ordination techniques, these predictors can be combined with response data collected on forest inventory plots to order tree species along environmental gradients. The location of plots in this feature space can be used with the k-nearest neighbors algorithm, which works by assigning to every pixel a bucket of plots based on their proximity as measured in the feature space. The contents of each bucket represent a group of records stored in FIA's database from which we can make pixel-level predictions, quantify uncertainty, and map a variety of forest attributes. This multispectral image combines three variables: stocking, age, and height. The pink in the southeastern U.S. shows the moderate height and stocking levels of the young forests of the nation's wood basket. Our plans for the future include analyzing snapshots from the past, using both imagery and plot measurements from earlier time periods to map changes over time, such as this map showing losses in forest carbon between 2005 and 2015 in Wisconsin due to major disturbances like wildfires and tornadoes. Next, Chris will show you how these services are being used today and how you can access them yourself.
BigMap is our end-to-end solution to integrate the latest in ArcGIS system, multiple programming languages, and state-of-the-art statistical tools to create information products for a wide spectrum of users. We are excited to share with you our vision of using these services today and in the future. Droughts are having huge impacts on forests and woodlands, and agency scientists are already using BigMap results, like this forest type group, to make drought model projections available widely. Examining drought exposure from recent years. The area in brown around the Central Valley in California shows significant droughts during this time. Projecting forward to 2040, drought exposure shifts from Central California to the Southern Rockies. let's take a look at how you might use our new authoritative content for a different problem. Recently, we were asked to help identify landscapes that represented opportunities for planting and increasing sequestration of carbon in trees. And to do that, let's take advantage of our FIA stocking percentage layer, which can be viewed as representing where additional capacity might be located. And let's focus on the Pacific Northwest and add data to a suitability model, FIA stocking and site class productivity, wildfire hazard potential from our Missoula Fire Lab, and pest and pathogen threats from our Forest Health Protection Program. We are looking for areas where planting opportunities exist without significant threats. The results, highlighted in purples, are areas where threats are low, productivity is high, and forests are not fully stocked. Now, this demonstration suggests a lot of opportunities might exist in Western Oregon and Western Washington. These could be important areas to realize shared stewardship, to implement climate mitigation, or restoration plans. And that was 2 examples of how you might consume these services in your own analyses using notebooks, geoprocessing tools, raster functions, and more. Today, we are excited to announce the release of our new hub, the FIA Geospatial Showcase, hosting all of the content we have shown today and more. Our hub represents a meeting place where we're sharing our best science and data in order to facilitate collaboration and empower your efforts to create a sustainable future. We will regularly add new content, eventually publishing other information products derived from our database. With consistent science-based information from FIA,
their methods. This is exactly the kind of that I admire. Many of you are implementing this concept of geospatial hubs and engaging with other communities. This trend and the technology associated with it first started with engaging citizens and cities. It's all about organizing initiatives and then organizing the teams and organizing their activities. But this is now, especially in the last year, expanded to organizing professional relationships between users of different types. This technology and the organizational strength of the people behind it is fostering many new types of geo-collaboration. And I love that concept because it's essential to make the concepts of geospatial infrastructure work. I'll summarize what I've been talking about. Our world is being challenged on many fronts, and we will increasingly need to be responsible for its future. Part of this presentation is about getting us even conscious about it among ourselves. The geographic approach and geospatial infrastructure, this rapidly expanding new pattern, is going to provide us with the science and also the practical means, the essential means to be able to make this work. But they're not going to be enough. You and your work are going to be essential, providing leadership in your own organization, carrying out problem solving, the kind of things you already do, but thinking larger, thinking holistically. My place in my organization, my organization's place in the world. Promoting our best tools and methods and thinking, being able to communicate clearly and effectively, and most of all, collaborating with other kinds of organizations, exchanging ideas, which I really wish we could be doing here together physically. This informal communication is so very important. Also, for me personally, I feel like I'm all in. I'm going all in. And I really want to encourage you to go all in. Act with urgency. These are the times where we really have to get it together and move at many different scales. I'd next like to move on in my presentation to talk about our work, the work that we do to support your work, and that's exactly how we see it. ArcGIS is our essential technology that we continue to evolve, and I'll go deep into what we're doing and have been doing in the last year in that environment. The vision of ArcGIS is to create a complete, comprehensive geospatial platform that supports multiple communities. The GIS community, of course, but also the mapping and location analytics communities, and also support geo-enabled systems, which are specialized technologies for specialized workflows. We do this in an open and developer-friendly environment with SaaS and software, and most recently, platform as a service. I'll talk more about that in just a moment. ArcGIS supports 3 fundamental types of systems, but they're all integrated into one technology. Systems of record for transactional data management, systems of analytics for creating insights into how geography is interconnected and works, systems of engagement through apps and maps that connect populations to the organization's work, communicate, and so on. ArcGIS is an integrated system. It brings many components together and works actually and has been engineered to work as a single system, supporting many kinds of applications and people. It, as a technology, is what is enabling and fueling this geospatial infrastructure pattern. ArcGIS users are increasingly leveraging the cloud. They're extending their system and strengthening their capabilities by deploying in clouds, like the ArcGIS Enterprise, but also leveraging SaaS resources from the cloud, like content or analytics in the cloud, or I'll be talking about a number of these things in a few minutes. Our pattern here is ArcGIS Online. The ArcGIS platform is open and it's interoperable. We support and leverage multiple initiatives to make this happen, supporting, of course, all the good work done by the standards organizations, OGC and others. We also have architected the system to be an open architecture with open APIs and open data so that it can help our users integrate their systems into a broader frame of other IT systems. We have been working during the last year on enhancing capabilities. They're advancing. Over the next few minutes, I'm going to be sharing a bit about each of these different activities that we're working on. But these are just kind of a preview for what's going to be shown in the next couple of days in various workshops. Lots of new innovations, specialized applications in many frames. I'll start this presentation by updating you on ArcGIS's content. ArcGIS content is integrated in part of the fundamental system, and it's really ready-to-use content. Thousands of layers that cover the Earth and also are curated by us from public sources made available so that they are literally, again, GIS ready. Look at the list on the right. These are some of the new initiatives to be able to take the NGDA data sets from the US federal government, sometimes called A16, and make them openly available for download and services for your application. And it just goes on. But one of the big ones I want you to notice, the new content that we created in the last year, which is a land cover map for the entire planet. These data sets are for global applications, certainly, but also they are of the nature of being very detailed in many geographies that can be applied for your work. Let me go on to this global land cover 2020 data set. This is high resolution imagery, the Sentinel imagery from the European satellite, which has been classified into basic land cover. And this is open data now available to all of you as services or downloads. And we built this in collaboration over the last several years with the National Geographic Society and Impact Observatory, and also Microsoft Corporation and their planetary computer. Powerful, exciting. Well, let me go on to desktop mapping and cartography. Here, we've been making improved tools and improvements to our tools to support advanced workflows in the desktop environment of ArcGIS Pro. We've added new things. We've certainly achieved parity with the ArcMap technology of the previous era, but also we have advanced new things, introduced new kinds of cartographic tools for advancing cartographic science. And there'll be lots of sessions on cartography here at the conference in the next few days. In the field of interactive web mapping, we have also made a lot of new improvements. The first word that I chose here is fast, because the performance of being able to do interactive mapping has, again, dramatically increased. And that's enabled things like data-driven exploration of maps. Look at the upper left. See, I'm moving back and forth this little chart, and we're seeing all of the counties in the United States visualized dynamically as we explore the information. That's a new pattern for maps. It's the idea that mapping is an interactive environment. Some of the improvements are that we introduced a new map viewer for both ArcGIS Online and the enterprise technology. And you can look through the list, you can find your favorite things. Mine happens to be sketching, the ability to sketch on top of a web map and then share it with my colleagues. Instant apps are a brand new thing that were introduced this year. They allow us to quickly transform any web map, 2D or 3D map, into an app. And we support about a dozen of these apps. You can just take your map, associate it with this app, and boom, you've got an app to go. And there's many more coming. For some of you, you'll remember the word configurable apps. This is kind of the next gigantic step forward of configurable apps. You can build these independently, but you can also create them right inside of the map viewer. For many of you, dashboards are almost an essential element now. I see them in almost every agency that I go to because they provide dynamic, real-time visualization about any subject. Well, for every subject, dashboards have meaning and have been embraced by our users to be able to provide at-a-glance information. We continue working, and what's coming is a new table visualization and the ability to have dashboards natively implemented on your mobile device. That means that people can look at their little favorite dashboards anywhere, anytime, and on any device. Story maps are, again, one of these enormously popular applications. They're opening up geographic storytelling for all of us. Everybody has a story, and they're telling it like crazy with story maps. Millions of these have been published. Thousands of new ones introduced every day. My good friend Jim Fallows calls this geojournalism, the ability to author a story and make it available dramatically, dynamically, digitally, covering a lot of populations. The innovations here have been better, simple drawing tools and the ability to collect multiple story maps together into collections, so I can publish like a story book for a particular community. These are getting easier, and the story map role last year opened up story map telling in a very affordable way to entire enterprises, and we're going to continue on that journey of making this more available and easier to use by everyone. Embedded mapping is an idea that I talked about earlier, the idea of embedding our mapping and our tools inside of other organizations' apps. And this is about embedding ArcMaps into other products, like all the Microsoft 365 products or the Autodesk tools for engineers, or into the Adobe products, or into Salesforce and Amazon and SaaS and IBM and others. My sense is that this is going to be continuing to expand your reach, the reach of GIS, bringing easy map making inside of other technologies. Well, I think that has the potential of really making transformational impacts. Our work in interactive visual analytics is largely organized in a product we call ArcGIS Insights. And this is a very easy to learn tool that works in both web and desktop environments. It allows people to access lots of different data around their organization and engineer access, and then explore the data visually, spatially,
that vary from extracting features like building footprints, classifying land cover, and many more. With the building footprint extraction model selected, we can now run the tool and get our results for the entire island. Here are the results from some of the deep learning packages done in less than a day. 55,000 building footprints, roads across the island, and a complete land cover classification layer. These are just some of the capabilities available in ArcGIS Image for ArcGIS Online. To take a deeper dive with more advanced raster analytics, I'd like to hand it over to my colleague, Kate Hess.
Now that Yoon has created foundational GIS layers for the country and hosted them in the cloud, I can easily access the data remotely. I'll tackle our next challenge using the power of raster analytics in ArcGIS Online. Grenada has rugged topography and faces frequent tropical storms. As a result, they regularly experience landslides, which can damage homes and businesses, disrupt transportation, and even lead to injuries and death. Let's identify infrastructure that may be at risk by using a process model to proactively locate areas susceptible to landslides. We'll perform this analysis using tiled imagery layers hosted in ArcGIS Online, including our land cover classified from imagery, the digital terrain model, the soil types, and the distance to river features. We're going to calculate landslide susceptibility from these layers using raster functions, all within the map viewer in ArcGIS Online. The Analysis tab gives me access to the raster function editor, which we'll use to create our image analysis process model. Here, I have access to more than 150 raster functions out of the box, including mathematical operators, geometric functions, and radiometric functions. These can be chained together to create new raster function templates for more complex operations, like my landslide susceptibility workflow. This processing chain takes in the 4 layers in our map and normalizes them to a common value range, then takes a weighted sum to identify the areas susceptible to landslides. Let's zoom in to evaluate a preview of our results. Previewing the analysis before running the model allows us to gauge if the result looks reasonable, or if we need to make adjustments to our input variables or to the weighting in our raster function. In the preview, we can see in red the areas at high risk, and the areas least likely to see a landslide are in dark green. When we're happy with our model, we can run our final analysis to get a persisted product. This analysis in ArcGIS Online takes only 1 minute and 30 seconds, so let's jump ahead to the output. Now we can see the areas with high susceptibility to landslides for the entire island. Let's bring this output layer into a 3D scene so we can visually explore the relationship between landslide risk and elevation. In 3D, I can clearly see how slope steepness relates to landslide susceptibility. Let's get a better understanding of what infrastructure may be at risk by bringing in the building footprints and roads that Yoon extracted from imagery. These layers are easily accessible to us since they're hosted in our organization in ArcGIS Online. In 2D, we can clearly see that this building falls within a high-risk area. But now in 3D, my attention is also drawn to this road, which falls within an orange area, but would be impassable if there were any significant landslide above it on the hillside. This is just the beginning of what we can do with hosted imagery layers and deep learning models in ArcGIS Image for ArcGIS Online. All of this was created in the cloud, so we didn't need to set up any infrastructure to run our analysis. We can also use point cloud data and ArcGIS Pro to bring our buildings into 3D. This gives us additional context for the building on the slope, as we can now see its height and shape, and how much of the structure is built on the hillside. With the additional capabilities of ArcGIS, we can continue to build out our countrywide database and foundational GIS, including bringing in LiDAR data to see our vegetation and power lines. We now have a 3D base map for the entire country. As a result, we have a building inventory for census planning. With the additional data layers, we can have an approach to natural disaster response that is more data-driven. And urban development, like here in St. George, can be intentionally planned and sustainable. All these capabilities, hosting imagery, deep learning models to extract features, and sophisticated raster analytics, are now available in the cloud.
Thanks very much, Kate, and also thank you, Yoon, for introducing this very powerful technology. And I think you can now see why I'm so excited about being able to put imagery in the cloud and allow these massively scalable capabilities be put in the hands of virtually every user. Drone mapping is another dimension of what we are doing with imagery. We support two fundamental technologies: site scan, which is cloud processing, and drone to map, which is desktop technology for planning and managing and collecting imagery and then processing it. This is what we are beginning to call reality capture. It is a mission that results in things like point clouds or DSMs or multispectral thermal emissions, lots of data sets that are directly usable by our users. For some users, they wish to do this at scale. So we introduced late last year a new technology called Sure for ArcGIS. This is about reality capture in an automated, like a factory, the capturing of this data, the processing of this data, and the ability to create 3D data products and maps. This is very, very attractive to large mapping agencies or to aerial survey companies who wish to automate and transform how they do digital photogrammetry. I'd like to show you how this works. You can see the textured meshes on the right in the city of Boston. It can now be integrated and enrich 3D systems of record, like the 3D buildings that's shown on the left. Many of you have these 3D systems of record that you're updating feature by feature. But by being able to integrate the two together, I can create really a marvelous 3D visualization experience. This is an example in Frankfurt, Germany, where an aerial photography mission was processed simply in a few hours to create this beautiful pictorial description of the city. And I can interact with this, of course. It's a beautiful visualization. But what you don't know is behind those, let's call them 3D pictures, are the actual 3D features. So I can interact with the features. I can color them. I can color the mesh. Like in this case with zoning. Well, the little video here speaks for itself. You get the idea. I see a new generation of 3D GIS as a result of these meshes being captured and being able to be integrated into our 3D systems. Our work in 3D visualization and analysis is fundamentally advancing GIS. It's not just about meshes, but also we've been working on the integration of game engine technologies to support immersive experiences. We continue working on tools for doing 3D web editing, both of meshes, but also of individual features. We've done extensive work in the integration of BIM models. We started in a great partnership with Autodesk Corporation, and we've extended this technology to include open BIM models or IFC integration. And we're also working actively on the ability to integrate these 3D BIM models right into our feature databases as a long transaction, and lots of other things, like being able to interactively do view sheds or cross sections or elevation profiles of various types. I'd like to share with you particularly the next chapter in our GIS and BIM integration. We're doing this closely with Autodesk Corporation, linking our systems with their systems and workflows. Now, ArcGIS GeoBIM, a new product which will come out in the fall, is able to dynamically link ArcGIS features to documents within the Autodesk Construction Cloud and BIM 360 environment. That means I can point at a feature in a 2D or 3D scene and automatically bring up next to it, dynamically bring up the document. And we have engineered this in such a way that this dynamic relationship can be the platform for creating a whole new class of apps. This will enable new kinds of collaboration, bringing the engineering and construction community closer with the GIS community and vice versa. Our 3D capabilities in ArcGIS are integrated across the entire ArcGIS system, and they enrich all types of experiences in the desktop, in the mobile environment, and also on the web. These experiences are part of a larger system, a complete 3D GIS system of record, a kind of living digital twin. Another dimension of our work is integrating real-time visualization and analytics into a GIS. This is about integrating sensors, the IoT, directly into the GIS, and we have two solutions to do that. The one is the GeoEvent server, which is an extension to the actual enterprise software. The other one is a new capability called Velocity, which allows these kinds of functions to occur inside of the ArcGIS online cloud. This is all about ingesting real-time data and visualizing it and analyzing it and bringing it right into dynamic applications of all types. For many of you, data management and editing is the center focus of your work. And here, our activities include continuing our support for all the leading data management technologies in the cloud and on premises, but also reaching forward into the future. We're integrating ArcGIS with these cloud data warehouses to enrich and do big data kinds of operations. We're continuing our support to advance industry data models, services-based models like parcels and utility networks and so on. And we've also made improvements in the geodatabase in performance and a variety of other things. Finally, we continue to work on improving our editing tools, new QA/QC tools, new integration of 3D features and meshes that I talked about earlier. And moreover, just this steady march of improving performance and scalability and usability all around. In the field, ArcGIS supports a series of field apps for both operations and data collection. The biggest innovation that we introduced last year was the ArcGIS Field Maps app. This actually brought together many individual apps' capabilities for collecting data, updating data in the field, tracking where you are, and being able to access services-based visualization tools. It also introduced the ability to do markups on top of maps and share them. ArcGIS supports a series of specialized data collection tools like Survey 123 and Quick Data Capture, and also it locationally enables other aspects of field work like with Tracker and Navigator and Workforce. All of these come together around the system to be able to provide operational awareness for people in the office who are tracking their people in the field. App builders are making it easy for our users to build their own apps. This is an environment where there's no code or low code app development. You simply take widgets and build web apps with the web app builder, which has resulted in millions of apps being built, and also the experience builder, which is the next generation of the web app builder, which is more optimized for mobile environments and also has better mapping. For those users who wish to build native mobile apps, we also have a technology known as the App Studio that allows you to build fantastic iOS or Android or Windows environments. And all of these app builders are available to all of our users. The result has been kind of an explosion of custom apps all over the world. ArcGIS supports strong developer capabilities. These are APIs and SDKs for automating and extending ArcGIS on one hand, but also creating whole new apps. Things like the Python API are useful for being able to build scripts and notebooks for automating work. Tools like the Pro add-ins with the Pro SDK and Enterprise SDK allows us to extend basically functionality. In the area of creating apps, our runtime SDKs allow users to create device-specific apps. And you'll see later today
the ability to embed these runtime SDKs inside of game engines, which open up a whole interesting world of gaming as it relates to GIS information. Or perhaps our most popular API is the JavaScript API, and this has resulted in millions of web apps. Earlier this year, we introduced a new library of tools, open source APIs like OpenLayers, Leaflet, and more. I'd like to take just a moment about the JavaScript mapping API, which is really continuing to advance at a very fast rate. Faster performance, data-driven visualization, new tools and widgets and workflows, more 3D capabilities, and especially client-side analytics that you saw in a few examples I shared a few moments ago. ArcGIS Platform is a brand new technology we released earlier this year. This is about developer-focused mapping and location services, and it's still delivered as PaaS. It's delivered in a consumption-based business model, which supports non-GIS developers and also the embedding of location services capabilities from the cloud into enterprise systems. Ladies and gentlemen, we're going to take a few minutes break, enjoy a mind rest with music and visualizations by Kevin Eubanks. Many of you know Kevin because he comes to our users conference regularly. He's a world-famous jazz musician, but he loves geography and he loves nature. And well, I love him. He's just an amazing man. This will be followed by a series of capability demonstrations hosted by Madeline that'll take you through feature function demonstrations of the great capabilities that I talked about in the last few minutes. Kevin?
hope you all enjoyed the inspirational music from Kevin Eubanks and the stunning nature visuals. I'm Madeline Shoren from Esri's Geo Experience Center. Next, we want to continue to share how GIS is creating a more sustainable future as we highlight a series of presentations that illustrate new and innovative approaches and capabilities of the ArcGIS system. Let's visit southwestern Colorado and the beautiful Telluride ski resort. To manage their complex operations, the team at Telluride uses ArcGIS Online's cloud capabilities to build a digital twin of their mountain. So let's hear from Brandon Green, the Director of Snowmaking and Capital, and Matt Tarkington, GIS Analyst and Drone Operator.
Welcome to the Telluride Ski Resort. This is our office. Today we're excited to give you an inside look on how we use Cloud GIS to manage our mountain every day. So here in Telluride, our mountain ops teams collectively manage roughly 2,500 acres of terrain on both private and Forest Service lands. In the summer, this includes golf, hiking, biking, and zip lines, but in the winter, we're best known for our incredible world-class skiing. Our number one goal is to always deliver the best guest experience, while at the same time, never sacrificing safety, maximizing efficiency, and being good stewards of our land. Our typical winter ski season runs from Thanksgiving to Easter, but our operations to support that window of opportunity are year-round. What most visitors to Telluride don't ever see are the people, time, and assets that go into making skiing on these mountains a reality. If we do it right, most people never see or even think about what's hidden below the snowpack, inside the pump houses and motor rooms, or what's happening out on the mountain after dark. GIS helps us track, maintain, and organize our assets, then visualize and leverage that information into our everyday logistics and long-term planning.
Our small GIS team here in Telluride are providing a cloud-based geospatial infrastructure, or digital twin, that enables on-mountain staff, dispatchers, managers, and execs to have access to the same real-time information they need to make rapid, informed decisions. For example, our snowmaking crews use field maps and dashboards to keep track of snowmaking infrastructure and share information in real time. Ski Patrol uses surveys and dashboards to report on avalanches, manage explosives inventory, investigate accidents, and monitor weather patterns. Dispatch utilizes dashboards to supervise open and closed terrain and get an overall view of our mountain operations. I'm most excited about taking real-time data from all of our sensors and disparate systems and make them readily available in a suite of common applications. Really, we are one big 24/7 operation. Most staff work their entire shift out on the mountain. Easy access from the cloud to mobile devices is essential for the success of our mountain operations. Complex terrain and elevation are major factors in everything we do. The amount of energy it takes to move equipment up, down, and across the mountain drives our economics and our decision-making. Over the last year, we've expanded our drone collection and mapping efforts, creating maps and scenes that help us understand and convey every detail of the mountain.
But our biggest challenge, by far, is snow. Getting a snowpack to the proper depth, width, and location is something we just cannot schedule with Mother Nature. So we continuously innovate when it comes to snowmaking and integrating real-time GIS to provide the best possible skiable surface to our guests every day, every season, year after year. And it's our digital twin that helps us do that. We can now look to the future and plan our long-term sustainability so that we use the least amount of natural resources moving forward. Now, while Matt and I would like to share more with you on how we're preparing for this winter season by integrating real-time GIS, advancing our drone operations, and improving our snowmaking, we're going to have to let our friends at Esri do that because we have to check in on the progress of our latest automation project. So the next time you're thinking of heading up to the mountains, remember, you're always welcome here at the office.
Thanks, Brendan and Matt. A small team leveraged a Cloud GIS implementation pattern, and a fast-moving mobile workforce is enabled. This story really illustrates the value of real-time information for rapid decision-making. So let's fast forward to the winter ski season, where Suzanne Foss, the ArcGIS Velocity product manager, will share how Telluride is advancing their real-time capabilities for fast decision-making and improved safety.
I'm really excited to show you all some of the ways we're collaborating to bring real-time geospatial awareness to operations at Telluride for the upcoming winter season. What we're looking at here is a dashboard with the kinds of real-time information that come from Telluride's operational systems. There's a wide range of equipment, assets, and staff that support commercial operations and resources management at this massive facility. For example, the chairlift system reports information on dozens of kinds of telemetry. And it's important for the team to understand immediately if there's been a fault in the system, because most faults cause the chairlift to stop moving. Understanding the type of fault and getting that information to the right mechanic as soon as possible is essential to get visitors moving again. The team also monitors information from the water pump system that supports snowmaking operations. The water pump houses provide information on flow, pressure, and allows the team to understand how much water is getting to the snow guns. Telluride has close to 400 snow guns, and understanding if they're online and running as expected is critical for optimizing field maintenance and reducing costs. Now, in addition to all these mechanical assets, Telluride is also working on enabling the tracking of key personnel. Most staff out on the mountain carry a radio that reports their location every few seconds. And going forward, Telluride is looking to map this radio data and begin to track certain types of personnel, like ski school instructors, ski patrol, and maintenance crews. And staff on fleet vehicles are also equipped with GPS units. This includes vehicles like snowmobiles and snowcats. We're currently working with Telluride to bring all these different data streams into a comprehensive, dynamic view of their facility, using the SAS-based real-time capabilities of ArcGIS Velocity. Real-time data from operational and asset tracking systems can be ingested with ArcGIS Velocity using feeds. Feeds enable you to connect ArcGIS directly to IoT systems, like cloud platforms, web and messaging brokers, and data providers. Creating a feed is easy. You choose the type of connector, connect to your data stream, and configure your data model. Feeds are continuous cloud-hosted service that ingests data and light up your maps with streaming information. And we're working with Telluride to implement feeds for all these different data streams that they want to monitor. Real-time data ingestion and visualization is an important part of geospatial infrastructure and for Telluride's vision of a digital twin of their mountain. But situational awareness goes far beyond just looking at a live map. The team also wants to identify incidents automatically and drive alerts to the people that need to know. For example, they want to ensure a safe working environment for staff that are out doing different jobs on the mountain, who are often in different vehicles. Staff in snowcats that are out grooming snow on the slopes often have limited visibility due to terrain, weather, and the fact that they often work at night. So they may not always be aware of who's close by, like staff on snowmobiles that can be moving very quickly. What the team wants to do is identify incidents when snowcat operators and staff on snowmobiles are too close to each other. And what's even more powerful about these streaming data feeds is that they can be leveraged in real-time analytics to perform geofencing, incident detection, and drive alerts. This real-time analytic takes the feeds of both the snowmobiles and the snowcats and geofences them against each other to identify locations where they're within a given proximity. Dynamic geofencing like this is a new beta capability in ArcGIS Velocity's latest release, allowing you to perform spatial enrichment, joins, and distance calculations between two streaming data feeds in real time. So let's see how this dynamic geofencing is applied in this use case. First, for each snowmobile position that comes in, the point is enriched with a grid cell from an overall hexagon grid surface across all traversable areas of the mountain. This is over 120,000 polygons, representing areas that are trails or non-forested locations. And for each of these individual grid cells, the area within 250 feet was also pre-generated. This represents the area that a snowmobile could actually reach from any given location. And this traversable area analysis was done because a simple distance calculation between two assets can report that they're close to each other, even if they're actually separated by a barrier. Like in this case, these two assets are separated by a tree line. So in the real-time analytic, each snowmobile position is first enriched with and then transformed into its traversable area, which are the areas shown here in orange. These are then used as a dynamic geofence against the position of the snowcats. If any snowcat is found to be in the traversable area of any snowmobile, an incident link is created, and an alert can be sent to both operators, giving them a heads up to slow down and look out for each other. In order to run an efficient and world-class facility, Telluride has to manage a wide range of assets and equipment and ensure a safe environment for field operations. With the SaaS-based feeds and analytics in ArcGIS, data from disparate systems can be seamlessly integrated into your geospatial infrastructure and provide real-time insights that operators have never had before.
Thanks, Suzanne. Implementation of ArcGIS Velocity, integration with sensors, snowmaking equipment, and personnel tracking, that's GIS expanding out into the many dimensions of their business. But let's fast forward through time again, switching to drones, to see the benefits that Telluride is achieving using SiteScan for ArcGIS as they fly over the steep terrain above town.
Hi, I'm Jeremiah Johnson, an imagery solutions architect here at Esri. And I'd like to talk about SiteScan for ArcGIS, our end-to-end drone solution, and how Telluride Ski Resort is using drones and some of the features that we've been working on over the past year. Telluride's drones are valuable tools for inspecting and modeling the mountain where it's difficult or impossible to reach due to the elevation changes and terrain that Telluride is known for. When building a digital twin of such a complex terrain, it is important to pre-plan the flights before going out into the field. These polygons represent sections of the mountain that were pre-planned based on the elevation, flight time, and line of sight requirements of the drone. This map is saved in ArcGIS Online, which means it's accessible in the field for drone operators using the Field Maps app on their mobile device. The flight crew can also use the Field Maps app to navigate to the designated drone takeoff locations on the mountain. What's great is that this map is also available in the SiteScan flight planning app. Drone operators can verify the area they're supposed to map and view the flight in 3D to confirm altitude and line of sight compliance in the field. Using a 3D terrain service, SiteScan generates a terrain following algorithm that ensures that the drone maintains a constant altitude above ground. This not only maintains compliance with regulations, but also ensures that each image has a consistent resolution over the ground. This creates a better quality data set once processed. SiteScan has another new feature that's valuable for flight planning, Corridor Scan, a unique flight mode that makes it extremely simple to create efficient, automated flights over a corridor with a fixed width and multiple vertices. Creating a corridor flight plan is as easy as selecting a corridor width, then dragging new vertices over the proposed corridor. This Corridor Scan flight mode, combined with a terrain follow functionality, is perfect for mapping trails, roads, pipelines, power lines, or any other linear feature. Telluride accomplishes mapping the mountain using personnel with a fleet of drones that map the mountain section by section. Each flight is automatically uploaded to SiteScan and our brand new fleet management dashboard available to administrators. Inside of fleet management, administrators can view drone maintenance logs and registration, pilot currency, and all the flight history for the organization. As the flights are completed, the photos are uploaded to the SiteScan cloud for processing. The resulting orthomosaic is incredibly detailed. This is due to the high-resolution drone imagery. Each orthomosaic can be placed on a single map where it is put together like a jigsaw puzzle. A fundamental enhancement to the power of SiteScan is the incorporation of the Shore processing engine for high-quality, scalable reality capture. Now, in addition to the high-resolution orthomosaic digital surface models and point clouds, SiteScan creates a beautiful 3D mesh that can be analyzed directly within SiteScan or published to ArcGIS Pro, ArcGIS Online, or in an enterprise portal. This 3D scene of the mountain was created from nearly 100 drone flights and over 15,000 images to create a single 3D mesh that covers the entire ski area. Leveraging the scalable i3s format, the entire ski area can be brought in and the dataset performs well in the browser and on mobile devices. This is a complete, accurate digital twin of the mountain. Its resolution is high enough that one can zoom into the beautiful mountain village, view Telluride's famous gondola station, and its journey to St. Sophia Station, and fly to Palmyra Peak, the highest point of the ski area, where we can zoom in to the details of the rock face. These are just some of the exciting new features of SiteScan for ArcGIS. SiteScan enables a new level of reality capture workflow that allows users to digitize their environment and enhance their system of record using drone technology.
Thanks, Jeremiah. It's so interesting to see how Telluride is using drones, building their digital twin and using high-resolution orthomosaics and 3D meshes as the foundation. Reality capture extends what's possible with 3D GIS, and that's the perfect segue to the next presentation that I'm personally excited to share. There are many ways that reality capture can extend 3D GIS, providing comprehensive data sets to perform advanced analysis. At Telluride, one way they're using reality capture is to calculate snow volumes, modernizing workflows to save time and money. Telluride, like many ski resorts, uses snowmaking to supplement the natural snow, improving the reliability of snow cover. This is a 3D mesh of the Misty Maiden ski area near Mountain Village and the designated snowmaking areas. Snowmaking forces water and pressurized air through a snow gun, producing concentrated areas of snow to be redistributed. The goal is to have 2 feet of snowpack over the summer terrain. We worked with the team at Telluride to develop this custom application that calculates snow volume, so the snowmakers know where they are in the snowmaking process. The blue areas show where snow can be cut to fill in the red areas where more snow is needed. This analysis was conducted using 2 digital elevation models, one showing the winter output and the other showing the ideal snow surface of 2 feet snowpack. The analysis can be rerun, this time using a new surface that shows 4 feet snowpack. And now the red areas will require almost 6,000 cubic yards of snow to meet the 4-foot goal, which is available based on the calculation. By utilizing the drone imagery captured in the winter, the team at Telluride is able to ensure that snow is made in the right place at the right time with the right volume, maximizing efficiency and minimizing cost. But let's switch gears and leave Telluride, flying to the San Bernardino International Airport, where they're also flying drones at their new UAS center. This view is quite the opposite of the mountains of Telluride, showing critical infrastructure. Here we can see miles of concrete taxiways and runways that need to be evaluated regularly for safety. Historically, this has been done in person, requiring hundreds of hours of on-the-ground survey work. But today, we can apply drones and artificial intelligence algorithms to expedite this process. These tools use AI and deep learning to identify pavement failures, quickly examining the runways and taxiways for cracks. Here we can see the output of the deep learning model, which identified cracking in between the slabs that's built into the concrete. It also picked up on some early cracking, so the repair process can begin as soon as possible. By identifying these cracks in their early stages, using drone operations and AI tools, the cost of repair can be dramatically reduced and safety enhanced. Switching gears, let's travel to the Netherlands and look at another example of reality capture, this time exploring a new development in the town of Almere. This is a 3D mesh of the area, created from hundreds of images collected by Caval 10. At 3 centimeters resolution, we can see incredible detail, including the sand dunes that the development is built on. The detail is exciting, but it's made even more powerful by using underlying GIS attributes to make it completely interactive. Clicking in the scene, for example, identifies the roads and parking spaces in the 3D mesh. Or we can quickly identify individual characteristics of buildings in the scene. We can also start to add in additional layers for information for more enhanced visualization. For example, adding in a living atlas layer from the Netherlands that shows traffic signs, or a 3D polygon to illustrate flood risk for sea level rise of 2 meters. Integrated 3D GIS combines meshes and features to quickly build a visually immersive experience, so we can travel to places like Almere virtually. Our last example takes us to San Francisco, where Esri partner Vexel created a beautiful 3D mesh of the city. With 3D GIS, a snapshot of reality is at our fingertips, giving us the opportunity to explore entire cities from anywhere in the world. This mesh has been brought in to ArcGIS Urban, one of our geo-enabled systems, to provide context for urban planning. ArcGIS Urban streamlines the development review process by by providing a shared view of activity across the city. Here we can see hundreds of projects that are currently active, overlaid on top of the mesh as a contextual base map. A major construction project that's currently underway is at 10 South Van Ness Avenue. Using ArcGIS Urban, we can visualize the proposed development in the context of the city and use spatial analysis tools to evaluate it. The latest release of ArcGIS Urban comes with a new shadow analysis tool, so we can quickly calculate shadow duration for anywhere in the city. Hovering over the analysis results, we can see the total time each individual area is in shadow. And as powerful as this visualization is, we can take it even further and get a view of the city from inside a new condo. This is now an immersive experience, creating an extended reality using the 3D mesh. Here, we can see the Transamerica Pyramid, and looking out the window, we can see Leavenworth Street. This is what reality looks like from inside a building that only exists in augmented reality. We can quickly swap out San Francisco for a 3D mesh of Denver, created by our partner Aerometrics. So we can imagine virtual cities all over the world. Whether you're a city planner, an architect, or even a movie studio, ArcGIS-generated 3D meshes create immersive virtual experiences. We hope you've enjoyed this quick tour of reality capture, real-time analytics, drones, and cloud GIS. Thank you.
I'd like to now shift gears for a moment and talk about the fundamental ArcGIS products. These are the vessels within which all this capability gets realized. As most of you know, ArcGIS is an integrated series of components: servers, desktops, apps, solutions, and so on. And I'm going to go through them systematically, and then we'll see some demonstrations of what's happened. Let's start with ArcGIS Pro. ArcGIS Pro is all about advanced mapping, visualization, editing, and analytics. And we've again introduced a whole new series of capabilities. But we also listened to your requests and feedback from last year, which said focus on performance, focus on quality, focus on usability. And we did that, but we also continued our march to add new capabilities, things like floor awareness or big data collections. And again, in the workshops, you'll see a lot of this material exposed. And there's yet again more coming. ArcGIS Pro has many extensions. These extensions extend the fundamental capability with rich analytics and tools for data management and tools for production, mapping, and charting. And again, there'll be specialized workshops on each of these. The second big technology of the family is the ArcGIS Enterprise. And this is about GIS infrastructure for your organization. It's all the tools for data management and mapping and analytics and collaboration of multiple types. This enterprise technology runs in public and private clouds, of course, and also for on-prem deployments. Lots of new things actually occurred here in the last year, some dramatically large advances, but I'll just hit on a couple. You've been asking for better distributed collaboration, like two-way synchronizations between different systems, updating a map in one system and having it send a little updatogram over to another one and automatically update, and many others. What's coming next is our support for enterprise in the cloud, and also the integration of our technology to these big data warehouses that I mentioned earlier in my talk. But I'd like to focus especially on a huge advancement which happened with this latest release, which is Kubernetes support. ArcGIS on Kubernetes is the implementation of ArcGIS in a cloud-native architecture. And for some of you, you'll be enormously interested in this when I tell you about it. Others will continue using Linux or Windows for the implementation. But cloud-native architecture means that we take a piece of software like Enterprise and we divide it up into a series of microservices. These are the little things that the software does. And you can deploy these on different computers within the overall cloud environment. This means I can really scale out the technology to deal with very large number of users or very high amounts of computation. This is not for everyone, but it is for organizations who are using Kubernetes and want to take advantage of this scalability. It's supported on AWS and on Azure, and also for users that use the IBM Red Hat OpenShift environment. The third capability or part of the ArcGIS system is the ArcGIS Online environment. And this is a massive global system for mapping and analytics, all in a SaaS environment. There are actually over 10 million users now that subscribe to this, and they're making millions and millions of data sets available for use by others. Trillions of maps actually get made out of this environment. And we're continuing to work hard on many fronts. I've already covered a lot of the new and improved capabilities in this system, like the new map viewer and charting and a bunch of others. Again, I invite you to the workshops here because you'll be able to be engaged and share what you're thinking about our work, and also share your feedback on our plans going forward. The ArcGIS Online environment has a number of extensions. One of my favorites I've already talked about is ArcGIS Hub. This is about supporting engagements with other citizens or with other organizations. Organization collaboration is supported with these tools. And I'll just underline this point that it's about organizing things. It's about organizing initiatives in an organization for collaboration or whatever. It's about organizing people, and it's also about organizing activities. Lots of neat workshops on this environment as well. ArcGIS solutions are a different kind of product. They lay on top of the other products. They're industry-specific maps and apps that are pre-configured. You simply download them and implement them into your systems, and you're ready to go for a whole new series of applications. They're extensive. They're transforming local governments quickly. We use this kind of pattern for the COVID response, where people were setting up dashboards very quickly. But in emergency response and utilities and so on, they're very easy now to deploy, and they're also completely supported just like our other software products. And the best part for many of you will be that they are free. They're freely disseminated, and they're helping organizations really realize huge value right away. We're now going to pause for a moment and see some amazing demonstrations of all these products that I've been talking about. That's going to be led by Madeline and Akita, showing the feature functions of how these capabilities are showing up in different products. So, Madeline?
Thanks, Jack. The latest release of ArcGIS Pro focuses on performance and productivity improvements, in addition to new capabilities. Let's take a quick tour of some of the new features in ArcGIS Pro, starting with cartography enhancements. This is Esri's world imagery from the Living Atlas that many of us use daily. Because imagery is typically gathered at midday, to reduce shadows, the texture of the terrain is lost. But ArcGIS Pro now includes new cartographic enhancements and blending tools, so we can quickly blend this hillshade with the imagery to give it more definition, so now the terrain really shines through. Blending can be used with other features as well. This layer shows California fire perimeters spanning over 100 years, with many of the boundaries overlapping each other. With this new cartographic capability, the features can be blended to understand areas of high fire occurrence, amplifying color intensity as the features overlap. So the highest incident areas are visualized in this bright orange. And finally, an overlay mode can be used to bring these two layers together, combining the fire perimeter data with the underlying terrain to create one beautiful map. Another exciting new feature is the ability to change selection symbology. With many overlapping boundaries and polygons, the default outline symbol can make it difficult to interpret the selection. By updating the selection symbology to a hatched fill, the selection set is much easier to see. So far, we've seen some of the new visual enhancements in ArcGIS Pro. But let me show you an improvement to the overall user experience that'll really help boost your productivity: command search. Now you can find any tool or feature in ArcGIS Pro with this simple search at the top of the ribbon. For example, I can quickly find the append tool so we can add 2020 fire data to our project. And here's another time saver. Now you can copy the Python command directly from the tool without even having to run it first. But let's switch gears and talk about a large fire that occurred outside of Yosemite National Park in 2013, the Rim Fire. One of the things that fire impacts most is land cover. So let's calculate the land cover change from the year before the fire to the year after using the new change detection wizard. The change detection wizard helps guide the workflow so we can conduct this analysis easily. Here we'll add in our land cover data and clip it to the fire boundary. And now we're ready to run the tool. The Rim Fire was a high-intensity fire that dramatically changed the landscape. Selecting the output of the tool, we can see that much of the area changed from evergreen forest to grassland and herbaceous land cover. To close out this section, let me show you two more updates to ArcGIS Pro, starting with symbology. Here we can see Yosemite National Park's trailheads and trail system data overlaid on top of the Rim Fire boundary, but the trailhead symbol colors don't quite match the rest of the map. ArcGIS Pro comes with a few updates to symbology. For example, we now have Pantone colors to ensure consistency while printing. But my favorite enhancement is the new eyedropper tool, which lets me interactively select any color from the map so we can quickly update our trailhead symbols. And finally, selecting anywhere in the rimfire boundary, new and improved pop-ups help us understand more about the fire itself. These pop-ups have the ability to split elements horizontally and vertically and use HTML for customization. They can also display 360-degree images, creating an immersive experience directly inside the ArcGIS Pro interface. This was a quick tour of some of the new visualization and productivity enhancements in ArcGIS Pro. Now I'm going to hand it over to my colleague Ankita to talk about and share another set of exciting capabilities called data engineering.
Thanks, Madeline. In ArcGIS Pro, we have added a new experience to help make your data analysis ready. This experience is called data engineering, and it will streamline your data preparation tasks by visualizing, exploring, cleaning, and transforming your data. Let me show you a few capabilities of the new data engineering view. This is the US county-level unemployment data for April of this year. I can right-click this layer and open the data engineering view. On the left, I see a list of all the fields this layer contains and their different data types. To dive deeper, I can select these fields, drag and drop them to the right, and click Calculate. We now see these powerful chart previews for each field and their summary statistics like minimum, maximum, standard deviation, all the way up to sophisticated statistics like skewness and kurtosis. These statistics help me understand the data. For example, the average unemployment rate is 4.9%. Over 9 million people are currently affected by unemployment. And the presence of outliers show me that some counties are suffering more than others. To visualize this data spatially, I will use the Update Symbology button. This button dynamically updates the map symbology for each field and helps me visualize spatial patterns. For example, we see stronger spatial patterns of unemployment rates in the western and southern parts of the country. I can also look at the predominant industry in each county. Another quick way to visualize your data is through charts. The Create Chart button automatically creates a bar chart for a categorical field like state name. I can select any state, for example, Nebraska, and click Calculate to see the unemployment statistics for just Nebraska. This visual and interactive interface helps me quickly understand my data, saving time and hundreds of clicks. Data engineering also includes a subset of geoprocessing tools to clean, construct, integrate, and format the data. Here are 3 examples. First, I want to show the Fill Missing Value tool. Here I have 14 counties with missing unemployment rates. I can right-click, select, and locate these missing values on the map. These are the independent cities in Virginia, and these missing values could be a result of upstream data processing. I can fix it using the Fill Missing Value tool. I'll fill in the tool parameters and run the tool. The tool estimates the missing unemployment rates using the values from the neighboring counties. And once completed, the new fields get added in the list with no missing values. The next two tools I'm going to show you will help you prepare your data for advanced analytics. For example, if I see a field that looks highly skewed, all I need to do is right-click and open the Transform Field tool. Here, I'm using a Box-Cox transformation, but there are many other transformation and inverse transformation methods available in the tool. And once completed, my data is now normally distributed, which is a requirement for many regression analysis. Next, I want to talk about dimension reduction. To train a machine learning model, we need more data. And with more data comes more complexity. For example, I have these 15 different age variables. I can select them and create a scatterplot matrix to find relationships between them. Here I see that some of my variables are highly correlated, which can impact modeling and prediction. I can fix it using the new dimension reduction tool. I'll reduce these 15 fields into fewer components whilst maintaining data variability. Using principal component analysis for dimension reduction is a very common data engineering step, and this is now built into the software. And without writing any code, I have reduced these 15 fields into 4 components that I can use to train my model. With the advancement in spatial analysis and machine learning, data engineering is more important now than ever before. And these are just a few examples of how this new data engineering view can help streamline data preparation and make it analysis ready. To close out our section, Madeline is going to show us what's new in ArcGIS Pro 3D editing.
Thanks, Ankita. Let's walk through some of the new 3D editing enhancements in ArcGIS Pro. This is a 3D mesh of the city of Munich. Captured in autumn, the beautiful colors of the changing leaves really pop out. 3D meshes are used throughout the ArcGIS system. So let's make some edits to this mesh to explore a proposed development of a new building. The first thing we want to do is grade the construction site to make room for the new development. Selecting the mesh layer, we'll add a mesh modification to replace an area of the mesh using an underlying 3D polygon. Now that the area is flat, we can add in a 3D model of the new development to explore in the context of the city. This is a 3D object feature layer that was created with Autodesk's Maya. With ArcGIS Pro, we can bring in a simple 3D model like this one, or a more detailed model like BIM. And while the building itself is a powerful visualization, let's add in some additional features like solar panels on the roof using the new Array tool. The Array tool quickly distributes additional features by adding in columns and rows that duplicate the original feature. So with just a few clicks, we've created our new solar panels. The last thing that we want to do is inspect underlying utilities so we can connect the proposed development to existing infrastructure. First, we'll expose what's below the surface so we can get a look at some of the underground utilities that are currently running through the street. And now we can add in a new fire hydrant and connect it to an existing water line. The new 3D grid feature helps guide our edits. And the vertical line capability lets us quickly illustrate how the fire hydrant will connect to the water main, simply snapping the edit into place.
All of these enhancements and many more are available for you to use today in the latest release of ArcGIS Pro. We can't wait to see how you incorporate them into your daily work. Now I'm going to hand it over to my colleague Kenyon Wilker, who's going to show you what's new in ArcGIS Online.
Hi, I'm Kenyon Wilker, and today I'm excited to share updates to 4 areas in ArcGIS Online. ArcGIS Online is Esri's SaaS solution for organizations that need to create, share, and explore maps, data, and apps to help solve geospatial problems. Many of us begin our data discovery and exploration in web maps. And I'm excited to share that the next generation map viewer is now in general availability and can be set as your default viewer. Let's use it to explore some enhancements to web mapping. Blending is one of the most exciting capabilities in the new map viewer and across ArcGIS. It takes the capabilities of top-tier graphic design tools and makes them directly available as cartographic visualizations. Here, we have world hillshade with demographics data on top of it. Normally, we use transparency to show these layers together, losing some of our color in the process. But now, we can use the multiply blend mode to easily fuse topography into our map, while keeping the informative colors of our demographics data. We can also use blending to further engage our viewers by focusing our map. In this case, we have a population density raster that shows more precisely where people live. We can use the destination in blend mode to show only where our demographics data overlaps with our population density raster, deepening our understanding of these demographics. Performance enhancements in the map viewer enable us to easily symbolize and dynamically explore our data. Here, I've symbolized thousands of census tracts by the percentage of the population that are renting. Using the range slider, the map gives us feedback, enabling us to explore our data dynamically. Now, let's explore charting in the new map viewer. You can create a variety of charts, including histograms, bar charts, and scatter plots. I've created a scatter plot to continue to explore our renting data along with the millennial population in the US. Notice that the chart automatically picks up my map's colors. On the bottom right, we have several outline tracks. Selecting them on the chart also highlights them on the map. And zooming in on some, the map continuously updates my symbology, enabling me to continue to explore this data dynamically. Next, let's explore what's new with configurable applications. With the recent update to ArcGIS Online, you can now create applications directly from the new map viewer. Let's create an instant app. And we'll use the minimalist template. Instant apps are a type of configurable application that enable you to go from map to app in a consistent and quick manner. In the application's express setup, we'll start by verifying the map and title, selecting our widgets, previewing the application on a variety of screen sizes, before publishing the application. You can see that we've quickly created an application with an intuitive and engaging user experience, where we can continue to explore demographics across the US. Next, let's look at what's new in dashboards, a configurable application that enables you to monitor and explore your data. Here, we have a dashboard showing outages across the US national power grid with PENS data from our partner GridMetrics. The GridMetrics PENS data is monitoring the health of the US national grid by watching the telecommunications network to see when and where it loses power, like here outside of Houston, Texas. And since dashboards are built off the JavaScript 4.x API, we can interact with advanced functionality authored in the new map viewer, including dynamically filtering clusters like these power grid outages, along with their dynamic labels. Next, let's look at another recent enhancement in dashboards, support for Arcade. Within a dashboard, we can use Arcade to extend functionality, enabling us to automate additional feature-driven visualizations and calculate attributes on the fly. Selecting an outage in Wayne County, Michigan, I see the list informs me what time the outage started at, but I also want to understand what the current duration of the outage is. To do that, we'll go into our list and add an Arcade expression that calculates the duration of the outage by subtracting its start time from the current time. The expression also highlights recent large outages. Another recent enhancement to dashboards is keyword search and multiple filter reset. Searching for Wayne County, Michigan, the Arcade expression informs me of our recent outages, and I can see our new duration attribute in the list, letting me understand the current time that the power's been out. Selecting one of the new outages, we can even view critical infrastructure like assisted living facilities in its immediate vicinity. And finally, one of the premier capabilities of ArcGIS Online is access to the Living Atlas, with thousands of authoritative layers and applications. Some of the most recently updated or added features include updated base maps, like new localized languages and stylized base maps, updated multispectral imagery, including new Sentinel-2 releases for land cover classification, updated population demographics, including the most recent ACS statistics, and even ready-to-use deep learning packages, like this one for Sentinel-2 land cover classification. Let's explore another new data collection in the Living Atlas, the National Geospatial Data Asset Portfolio, also known as A16 layers. We've worked with the US federal government to make these available through a centralized set of resources. They're a collection of authoritative, ready-for-use datasets that include high-resolution imagery, critical infrastructure, congressional districts, and more, that are updated regularly and available for anyone to display, use, or download. Next, let's check out an exciting new enhancement to one of our most popular base maps, OpenStreetMap, which is often a great source of foundational information in many places around the world. And nowhere is this type of support more important than rural or isolated places, like this mining town in the outback of Western Australia, Kalgoorlie. Zooming in on the town center, we can see that only the main part of the town has been fully mapped on the classic OpenStreetMap. But now, Esri includes the daylight distribution as the default OpenStreetMap base map, enhancing the great work of the OSM community with the help of Microsoft's MS Building Footprint AI model for additional geographic validation and levels of detail. ArcGIS Online is constantly growing and evolving, adding new capabilities and information with every release. When we bring all these capabilities together, we can create insightful and engaging applications like this one that uses cartographic blending, data from the Living Atlas, and the JavaScript 4.x API to display US ship traffic over the past 3 years. This is just a piece of all the new capabilities in ArcGIS Online available to you now. And I encourage you to try out these features and more to explore your data and solve geospatial problems. And now, I'll turn it over to my colleagues, Philip Peedy and Mark Carlson, to share some exciting news about the next evolution of ArcGIS Enterprise.
Welcome to our Network Operations Center, where we can monitor the resources that power many of our ArcGIS Enterprise deployments. I'm Philip Peedy, and I'm the lead product manager for ArcGIS Enterprise.
And I'm Mark Carlson. I'm a system architect, and I often use system monitors like these to help maintain the health of large ArcGIS systems and verify that services are within their service level agreement.
We want to talk to you today about a game-changing new deployment option for ArcGIS Enterprise. Some of you will be ready and interested in this today, and for the rest of you, this is a heads up, because this technology is likely to be of interest to you as well in the years to come. We've been hearing from many of you that you're increasingly setting up larger and more complex deployments of ArcGIS Enterprise to power an expanded number of workflows within your organizations. As Mark alluded to, the systems are getting bigger and more challenging every year. So let me introduce you to ArcGIS Enterprise on Kubernetes. It's a new deployment option for ArcGIS Enterprise, in addition to our existing offerings on Windows and Linux. It's fully cloud native, with a microservices architecture that provides inherent high availability without any additional configuration. For those of you already comfortable with modern cloud patterns, it built upon the same IT standards that you use in the rest of your organization so that you can reuse that experience and knowledge. And it runs equally well both in the public cloud and in your own private cloud environments behind your firewall. Building upon the industry standard and open source Kubernetes framework, you get the benefit of a simplified deployment experience as well as dramatically simplified upgrades. So let's take a look at how this can be of benefit.
During last year's spike in wildfires, I was hosting this wildfire feature service, and the demand of the service exceeded what we were expecting. So I had to add multiple machines to respond to the increased demand. Let me show you how ArcGIS Enterprise on Kubernetes can expedite this type of work. Here is the new manager interface. From here, I can see an overview of the logs, data stores, and even the service pods. Now, a pod is a deployable object inside of Kubernetes that contains microservices. And we can also view services by selecting services on the left. Let's view my wildfire feature service by selecting on the hosted folder. And then let's select my feature service. From here, I can see the overview status and more. I can also see how many pods are running for my feature service. And when I need to modify the resources available, I simply click on the Settings tab to view and edit the resources that have been prescribed. And instead of having to add entire servers to distribute the increased load, I can simply increase the number of pods or even increase the amount of CPU and memory. It's that easy to increase the resources available to a service. And I don't have to install any new software or do any other type of server configurations. And for our end users, ArcGIS Enterprise Portal looks and feels the same. We still have all the same tabs like Home, Gallery, Map, and others. So let's navigate to my content. Here I can see the items that I have published to ArcGIS Enterprise. And I can find my wildfire feature service that I published with ArcGIS Pro in my wildfire folder. And as you can see, it looks and feels the same. So let's have some fun with this feature service and see how well it scales when we place additional load on this service. For this service, I've created a Grafana dashboard that's a live view into my Kubernetes cluster. And it displays the network traffic, the number of pods available to my feature server, and the percentage of CPU usage. I have also configured ArcGIS Monitor to alert me when the response time of the service exceeds 1 second. And as we can see in the monitor dashboard, we are well below my threshold, and there are currently no alerts. So let's place some additional load on our feature service. And at first, the feature server is able to handle the requests, but then it starts to get overwhelmed as seen in the increased CPU usage. And when the response time of the service exceeds 1 second per our service level agreement, ArcGIS Monitor will also alert me of this increased load, as seen in the monitor dashboard. So let's add some additional pods to our feature server directly from the Settings tab of ArcGIS Enterprise Manager. Now, we are manually increasing the pod limit to 4, and with a little bit of scripting, this could also very easily be automated. And looking back at my Grafana dashboard, we can watch the number of pods increase to the number we just set for our feature server. And as these pods come online, the load for my wildfire feature server will begin to be distributed among them. And we can verify that our response time is now less than 1 second by viewing the metrics in the monitor dashboard. Not only can I scale efficiently, I can also leverage the cloud-native patterns for deploying, updating, and upgrading ArcGIS Enterprise. ArcGIS Enterprise on Kubernetes works with modern DevOps patterns for deployments. The automated deployment and preset architecture profiles simplifies my work and makes my deployments reproducible. I can use the same script for the dev, stage, and production environments, saving me a lot of time. All I have to do is edit the properties file for both the deployment and configuration scripts to have a fully automated experience. And for updates and upgrades, simply navigate to the Updates section of ArcGIS Enterprise Manager to view and apply the available updates and upgrades. Whether you're updating or upgrading, it's an automated process in Kubernetes.
So let's take a look at how these updates work behind the scenes. When updating or upgrading to a new version, we apply a number of techniques to reduce downtime and interruptions. And we do so smartly based on the type of microservice that's being updated within the system. One technique is the use of rolling updates, where we gradually roll in the new version as we roll out the old. This pattern is used for stateless parts of the system, where the old and the updated processes can coexist. This ensures a seamless update with no visible impact to end users, and the ability to validate that the update has succeeded before phasing out the old pods. The second technique uses what's known as a blue-green approach for upgrading, where the new and the updated microservice is created next to the existing one before then switching over to the new one with a virtual flip of the switch once it's ready. This is done for stateful parts of the system, where the old and the updated parts of the software shouldn't be running concurrently. Both of these techniques are used automatically by the update process as appropriate, and are entirely seamless to both administrators and end users. And the part that I like is that it minimizes any interruptions on my production machines and ensures confidence in the system for my users. To summarize, this is an exciting new deployment option that sits alongside ArcGIS Enterprise on Windows and Linux. ArcGIS Enterprise on Kubernetes provides you great new capabilities for designing, setting up, and maintaining highly available deployments with a minimum of administrative work. If you've already adopted a modern cloud strategy based on Kubernetes, this is designed for you. If you're not quite ready to take on Kubernetes and the change that it brings, don't worry. If you decide to go in this direction in the future, we'll be ready for you. Next, let's go out into the field and see what's new with ArcGIS field maps.
Hi, my name is Eric Wagner, and I'm a solution engineer on the water utilities team. Efficiency and accuracy are critical to effectively coordinating operations at utilities every day. To do this, you're probably using many of our current apps, like ArcGIS Quick Capture, Survey 123, and more to complete your work in the field. But you've asked us to combine many of these great apps into one. So in addition to those other apps you already use, I want to introduce Esri's newest mobile app, ArcGIS Field Maps. In its first release, it will combine the editing capabilities of Collector with the viewing and location tracking functions of Explorer and Tracker. Today I'm at a construction site doing some asset collection. Let's see how field maps can help me get my work done. Viewing and understanding the specific details about all of your utilities assets is critical to daily operations. For example, I can look up additional information about this valve at the end of the street. I can also take a look into its historic maintenance records as well, and in particular, see the work that was done last January. Field Maps also allows for the use of high accuracy GNSS receivers to collect newly installed assets, like this valve. With 2 taps, the location is recorded. Now information about the valve needs to be entered. Field Maps allows collected asset information to be placed into logical groups to simplify data entry. When combined with default values and drop-down lists, data collection is faster and easier. I'll set this valve type to gate and submit this feature. Snapping also ensures the proper placement of new features that I need to collect as well. I'll add a main segment to connect this newly collected valve to the other valve at the end of the street. Now I need to record some information about it. One of the exciting new features about Field Maps is the addition of smart forms. This functionality only shows fields that need to be completed for this new feature based on my inputs. Right now, I can only see general details, but when I set the main type to distribution main, an entire section with additional fields is now visible and already filled in with default values. Time is saved when I only see the appropriate fields as I collect data. Existing assets can be updated as well, and smart forms can make this process more accurate too. The yellow valve at the end of the street needs to have its status updated from open to closed due to construction in the area. I can tap on this valve, select it, and begin editing it to change its present status from open to close, and I'll see that a new notes field is now present to me. I can even fill this out using voice recognition software. Valve closed due to ongoing construction. And I'll submit these changes. The valve is now red for others to see that it's been closed, and the notes are there to explain to others why the status has been changed. I can also share information using markups. Notes can be added to the map for others to understand conditions on the job site. Due to active construction on the houses behind me, I can't GPS newly installed water laterals. So here, I'll add a markup to this location, and I'll add a note to it saying that construction is in progress and submit it. As you've seen, Field Maps allows data to be viewed and collected in the field, but it also lets users share their locations with managers throughout the day to improve coordination between field crews. I can turn on Tracker by tapping on the top of the screen and flipping the switch next to Track My Location. And if I want to see those tracks from throughout the day, I can turn this layer on in the map as well. ArcGIS Field Maps allowed me to more efficiently and accurately view, collect, and share data, all from one application. But what does it look like to coordinate an entire team of field workers? Let's go back into the office and take a look. No matter which apps you use out in the field, your crews and assets can be visualized in an ArcGIS dashboard. This increases coordination at organizations of any size through a common operating picture. Dashboards allow managers to make informed decisions with real-time data. Here, I can see information about my assets, field crews, and open work orders. Scrolling through my list, I can see we have a main break, which requires an immediate response. Since I know the locations of all of my field crews, I'm able to determine who's closest to this incident. And it's Jay, who's about a mile away, so I'll reach out to him first. And if additional support is needed, I see that I can reach out to Matt as well. As this situation unfolds, understanding all of my nearby assets, such as service connections or fire hydrants, begins to paint a valuable picture of what might be impacted when this leak is isolated. You don't get to choose when emergencies happen, but by having the right technology in the field and in the office allows you to respond with coordinated operations with time and efficiency. Now let's continue our journey and learn about the new features of ArcGIS Story Maps with Jennifer Bell and Ashley Dew.
Hi, I'm Jennifer Bell, and I'm the product manager for ArcGIS Story Maps. Today, we'll share some enhancements with Story Maps, both new and familiar. Organizations and authors like you are creating thousands of stories every day, with narratives ranging from climate change to racial equity to sustainability. Let me show you an example of one of these stories. I'll turn on autoplay to get an overview. This is a story about tree shade equity. Leaders from the city, community organizations, and universities are coming together to address the distribution of tree cover across Los Angeles. This immersive combination of text and media, including detailed images, informative maps, and engaging videos, bring life and meaningful context to your work, leading to understanding, which can bring an embrace of community and the possibility of change. Visualizing tree canopy with web maps like this one helps display tree shade inequities, especially across LA's diverse communities. Here, we see a contrast in tree canopy between neighborhoods. Story maps provide historical context for your narratives by visualizing timelines that help readers understand the history of the impacts felt today. And leaders can track progress and gather insights to improve their communities through embedded dashboards, surveys, and much more. Story maps combine text, maps, and media to help deepen the inherent value and power of any story. Now let's take a deeper dive into the new storytelling capabilities. And who better to show you than Ashley Dew, product engineer on the Story Maps team.
There are many exciting releases in Story Maps, capabilities you've been asking for. I'll share a few of them while we edit this story together. The first new capability I'd like to show you is the image gallery. It lets you quickly batch upload photos from your computer and easily rearrange them the way you want. Image Gallery combines your images into an attractive collage. We now get a glimpse into the work communities are doing to improve shade, like planting trees. In this sidecar, we've added an audio block to add a more human element to your story. Let's give it a listen.
Like many U.S. cities, Los Angeles is fighting to overcome the effects of urban heat islands and how they're impacting communities.
Another exciting feature is map actions. This web map highlights the striking differences in land temperature around LA. You can add map action buttons like these to navigate the map or turn layers on and off automatically. This creates a kind of map choreography. Here we have South Central LA with hotter temperatures compared to nearby areas like Beverly Hills or Bel Air that are significantly cooler. The next newest feature I want to show you is the timeline block. The timeline below allows you to visualize a sequence of key dates and events, showing how leaders in LA are addressing change across the city. We'll add one more event to highlight what organizations are doing today, with a title, description, and an image. Creating a timeline is that easy. Next, I want to show you a new enhancement with the swipe tool. As always, you can swipe a map to compare different layers, like tree canopy here on the left and building cover here on the right. And now, you can use the swipe tool to compare different images. Both of these are from neighborhoods in Los Angeles, one with dense tree cover and another with much fewer trees. And you can always leverage your GIS work through embedded apps, like your dashboards. This dashboard is used to track the progress of the City of LA's goal to increase tree canopy 50% by 2028. You can also embed your surveys, like this one, that helps gather community data on the impacts of shade. Lastly, I want to share with you some new ways that you can use a map tour. A map tour is an interactive way to showcase a set of related places. In addition to manually creating them, you can batch upload images or connect to a feature layer, plotting locations on a map in seconds. In this example, we've connected to our survey data to show responses, like Gerald, who wants clean air for his family, or Keisha, who's concerned about her grandmother walking in the hot sun. To finish this story, you can add helpful resource cards like these that show the ongoing work towards a more equitable and sustainable future. Next, I'll send it back to Jennifer, who will share 2 more additional capabilities on how to take your stories to the next level: themes and collections.
Consistent design, whether it's for your organization, campaign, or a specific initiative, strengthens your stories. This story uses the default Summit theme, and there are many other out-of-the-box themes to choose from. Let's apply a custom theme that speaks to our environment and to our community. We instantly see the environmental theme applied throughout the story in its background color, its fonts, its buttons, and much more. Here's how we create a theme using the new Theme Builder. Changing the main background color immediately sets a new tone for your story. Let's add a beige background, a dark green accent color, and hints of green and brown for the text. To provide a unique look for your story, there are hundreds of fonts to choose from. The Theme Builder also includes styles for your buttons, quotes, links, and separators. Let's apply this same image for our logo. I'll add a logo link and alternative text to ensure accessibility. You can share your theme with your organization for a consistent look and feel across all stories. Lastly, I'll share some exciting capabilities with collections. When you're working on a project, you often have lots of supporting work. Now you can bundle and share all of your work into a collection. You can add your stories, your apps like dashboards, insights, and surveys, and files. Collections are an excellent way to create your portfolio, bundle your newsletter, or give an interactive presentation. Let's apply the new magazine layout, which gives select items a nice spotlight, and we'll preview the collection. When we open this item, it takes us to a web map. Here, we're presented with a series of tabs to access every item in your collection, which helps readers easily explore and understand your work. Your work is crucial for real change, and ArcGIS Story Maps provides meaningful context your readers need. We're excited to see the impact your engaging stories have on your communities and in the world. Now, before we hear more from Jack, let's listen again to the moving music of Kevin Eubanks, followed by 2 new product demonstrations.
Thank you, Kevin, for joining us again at this year's user conference. So far, we've covered a lot of product technology updates earlier today. Let's continue with the next segment, where we'll take a deeper look at two new products we're developing, ArcGIS GeoBIM and the ArcGIS Maps SDK for game engines. Up first, GeoBIM.
Hello, my name is Anthony Renteria, and I'm the product manager for ArcGIS GeoBIM. As many of you know, building sustainable infrastructure is a complicated process. Critical data supporting project development is often hosted across multiple systems, making access to information difficult for decision makers. ArcGIS GeoBIM can help with that. GeoBIM links projects and workflows by interconnecting ArcGIS with the Autodesk Construction Cloud. You can create GeoBIM projects that link ArcGIS features to Autodesk records, which supports integrated visualization and querying, and improves project delivery. So let me show you an example of this complexity on a light rail project for infrastructure in the greater Denver area. Typically, GIS is used in the early assessments of how developments like this will be affected by the built and natural environment. And then, as we see in the Autodesk Construction Cloud, as we move into design and construction, the building information modeling process is introduced. Asset models and files are stored here and built collaboratively. Autodesk Construction Cloud manages engineering plans like you're seeing here that will be useful into the construction phase for contract documentation, but also to track issues for design and construction that will encompass quality, safety, and engineering specifications. Now, what we're seeing here are two distinct and separate worlds. So let me show you how ArcGIS GeoBIM brings these two together in a single app. What you're seeing here is, on the left, our GIS, which includes a base map, our infrastructure layers, and our building scene layers. And I've highlighted the rooftop AC unit equipment. And now on the right, what you're seeing is our Autodesk Revit model of this mechanical system to show the full route of the ductwork and engineering specifications. GIS and BIM are shown side by side to help with critical coordination of these detailed systems. And we can also do this for Autodesk Civil 3D models and AutoCAD files. When I select my rail feature, I can open up my link and begin to see this work in progress infrastructure drawing that we can share and collaborate around for the full project team. Now through GeoBIM, we're bringing this wealth of BIM and GIS together to improve coordination across the full project team. So let me show you how we can quickly link GIS and BIM in the GeoBIM Project Manager. First, by creating my account connection into the Autodesk Cloud. Next, I'll head to the Tools page, where I can automatically create links between my GIS and BIM. As I select my engineering documents and issues and click Run, GeoBIM will begin to search into my Autodesk project folder and begin to create boundary features that link back to the original BIM items. Now, this link information is useful, so let me show you how you can create our apps from this. Within the Apps page, we can create various applications, including those for documentation review, site context evaluation, and design and construction coordination. But finally, let me show you my issues dashboard, which will be useful for project managers and executives who need to understand and monitor project progress. We can also understand where these issues are occurring across the project. And provide transparency into the overall project process for everyone. As you can see, ArcGIS GeoBIM will provide a foundation for your projects. Whether you're in an AC firm or owner-operator, you can simplify team collaboration and put your projects on the map.
We believe that GeoBIM will bring the engineering, design, and GIS communities together. Our next topic includes GIS and immersive experiences like AR, VR, XR, and gaming engines. In fact, you've already seen a few examples, powered by the new ArcGIS Maps SDK for game engines. Here to share more is Adrian Mariot, the project lead for the Maps SDK.
Thank you, Madeline. Game engines are the perfect tools for creating visually impactful, cost-effective, immersive experiences. The need for photorealistic experiences in many industries means that game engines are being used today for creating more than just games or movies. They're used, for example, in military simulation, in urban scenario, or in management of natural resources. The ArcGIS Maps SDK for Unity and ArcGIS Maps SDK for Unreal Engines are two new products currently in beta on their way to join the Esri family. With these plugins, you'll be able to access the ArcGIS system from the two most prominent game engines on the market. Here, we're using the ArcGIS Maps SDK to stream those base maps from ArcGIS Online into the game engines and display them on the globe. Thanks to our partnerships with Epic Games and Unity, you can now build experiences in these game engines that can transport you all around the world. For example, here, we're flying through the Himalayas to get a good view of Mount Everest. So we are looking at our image and elevation layers displayed in the game engine environment. But we can also add our 3D GIS content. Now, we're going to travel to the city of Bendigo in Australia and appreciate the incredible data created by our partner, Areometrics. The details look amazing, even at the street level. Look at this pillar in front of the art theater, next to the historic fire station. The Maps SDKs make it simple to add these types of layers to the scene, and the development environment removes the complexity of dealing with large data sets and different levels of details. We are now looking at the courthouse right next to the visitor center. We'll pass quickly all the shops on Williamson streets, and the one on Hargreave Mall. We're now on the street that feels a little bit closed in. With game engines, you can import content from other applications. Here, we've created an urban planning scenario using ArcGIS City Engine, procedural building rules, and David Wessersman complete street rules. You can see how this design fits with the rest of the city. It feels now much more open and really enjoyable to just walk around. You could use this immersive experience to present to the city what the future of that city block might look like. With City Engine SDK, you can procedurally generate data directly inside the game engines. You can start with an empty parcel and just add a City Engine rules to it. Then, game engines will generate the building procedurally with the streets. You can also change the rules parameters, like the setbacks here, or the numbers of floors, directly, and see it happening directly on the game engine. Now, let's add some vegetation and street light to our experience, coming from the Game Engine's asset libraries. Look at those beautiful trees swinging in the wind. We now have a really beautiful looking digital twin of what that city block might look like in the future. Next, let's talk about the biggest advantages of using game engines. And those are visual effects and animations. This is how you can add another dimension to your experience. Look at this beautiful sunset, for example. You can see the light interacting with the tree leaf. Now the street light turns on at dusk, and you can look at the stars. We even just saw the moon. We can even change this sunny day into a thunderstorm. Particle systems are a key component of visual effects. Game engines provide easy-to-use tools to be able to create and control those particle systems. That's how artists can create effects like atmosphere, clouds, and rain. Not safe to have an umbrella anyway. Next, you can add and animate real-life characters into your scene. Having live character to your scene will really help everyone understand how the space will be used. Look at those people enjoying the outdoor cafe on a sunny afternoon. To bring more realism to our streets, what we need, of course, is cars. Cars' positions can be animated following a script or using real-world sensors. Oh, sorry, I need to move out of the way. Sorry. We've created this amazing immersive experience once, but we can deploy it to multiple devices. This one, of course, but also via headset, tablets, or phone. The simplicity of deployment is one of the reasons why virtual reality experiences are mostly built using game engines today. Let's talk about augmented reality now. I have now on my phone an application that allows me to look beneath the streets at the underground utilities. This is what we call real-life AR. Uh-oh, I think we're having a problem. Our newly designed cafe is on fire. Once again, we're using particle system to create this real-looking fire. And lastly, we can transition to this tabletop experience, giving us a top view of the city of Bendigo. Tabletop applications works as augmented reality on devices like phones or tablets, virtual reality on VR headsets, or mixed reality on devices like HoloLens. And they can all be powered with one single game engine project. They're good for situational awareness, advanced planning, and collaboration. Here, we're showing the position of the emergency responders on their way to the fire, represented by those red cones. We can also see the effect of the smoke on the city, depending on the wind direction and speed. And that was a quick tour of some of the things you can do when you bring GIS to the game engines using the ArcGIS Maps SDKs.
That was just a quick look at 2 new products we'll be releasing later this year. At this point, we're privileged to have a special guest from NASA's Jet Propulsion Laboratory to share a behind-the-scenes look at GIS that's truly out of this world. Without further ado, Dr. Fred Califf III.
Hi, I'm Dr. Fred Califf III from NASA's Jet Propulsion Laboratory. And today, I'm going to talk about mapping Mars for rovers. As you can imagine, sending a rover to another planet is a big endeavor. And we want to have the most accurate maps as possible so we can find the scientifically interesting areas as well as areas that are very safe for the rover to land. So it can't just be done by one person. It requires a large team. So we have people from the US Geological Survey that created our base maps, as well as people from JPL on the Terrain Relative Navigation team who took those base maps and provided corrections to the original data, such as the camera models and the instrument timings, as well as the people who helped find scientifically interesting areas and safe areas like the Council of Terrains, as well as people like myself who day-to-day make maps for both the science and engineering teams to keep track of where the rover is, where it's going to be, and all the science that it's done over the lifetime of its mission. So here's Earth. Looks familiar, right? You got the oceans, you have continents, you have ice at both the North and South Pole. And if you look close, you can see mountains and volcanoes and such. Mars is similar, but a little bit different, a lot drier. There's no liquid water on Mars currently because it dried out about 3 billion years ago. But you do see some evidence of water, such as the ice caps in North and South. It does get clouds, and you can also see things like mountains and volcanoes and valleys and places where we think water was in the past. So one of the exciting things about Mars is that 3 to 4 billion years ago, it was kind of like Earth. There was potentially an ocean, there was lakes, there was running water, and maybe, just maybe, the possibility of life on the surface, developing similar as Earth. Unfortunately, when we look at Earth 3 to 4 billion years ago, most of the rocks have been destroyed by plate tectonics. But on Mars, those rocks are almost completely preserved. So we go to Mars so we can see what Earth was like 3 to 4 billion years ago, as well as to answer one of these big questions: does life develop everywhere in the universe, or is Earth one of these only special places? So you saw that little white circle on that map. That's Jezero Crater. That's where we sent the Perseverance rover. And so here's a look at it a little bit closer. It's about 50 kilometers across. And that little blue grayish ellipse, that's where we wanted to land the rover, right near this river delta. So we think actually Jezero Crater was actually a lake, an ancient lake filled with water, and we see stream channels coming in and out, and that river delta where we're going to land that we think is the best place to look for past evidence of ancient life, ancient organics. So here's the Perseverance rover. It's about a SUV-sized vehicle, and it's composed of a variety of science instruments from a lot of different countries. For example, from Norway, we have the ground penetrating radar, RIMFAX. From France, we have the SuperCam instrument. And then we have instruments from the US like Pixel and Sherlock out on the arm, which will actually look for those organics within the rocks. We can also look at a 3D model of the rover. So here it is. And on the end of the turret, there's a bunch of instruments. We have Pixel and Sherlock and the coring drill, which actually take a piece of rock from the surface and put it into a tube for a future Mars sample return. We'll actually bring some of those rocks back in a future mission. We also have the MASS instrument where we have the science camera, MASSCAM Z, as well as that Cyclops-like eye SuperCam, which actually shoots a laser out to the rocks, vaporizes them, and then looks at the colors of that vapor to determine the chemistry and mineralogy. And so together, all these instruments make up the science package so we can investigate the science and the rocks on the surface. But we have to start with a map for the rover to land on, and for the scientists to investigate where's the best place to go. So we start by taking visible images from satellites in orbit around Mars, usually at 2 different angles, so we can create a stereo photo, so we can generate elevation models and slope maps and cost maps, so we can actually pretend to drive the rover over and see how long it will take to look at all the science areas. But so it's not only for safely landing on the surface, where are there big rocks or big hills and where can we go in between, but also being able to drive to these scientifically interesting areas and investigate the rocks that the science team is most interested in. So on a mission, we create a lot of maps. Everyone wants to know where's the rover now and where is it going. So we start with just maps of like a whole landing site. For in this example, a lot of maps from the Curiosity rover, the placement of different high-resolution images in the crater, maps of elevation and where the rover has gone and where it's been and where it's going to go. places where the rover had drilled into the surface and collected very high-resolution data sets and chemistry inside of its internal instruments. And just maps in general, keeping track of every rock that we've actually taken a picture of or shot with a laser or taken the arm out and put the instrument onto, as well as publications based on these scientific results so that we can share it with other scientists and the world. So Perseverance rover did something really special. Normally, our maps are used for landing in terms of a statistical sense, like this basic 25-kilometer area is safe to land in, but pretty much anywhere. However, Jezero was really special. Back on the Curiosity rover, Jezero Crater was deemed unlandable because with that landing system, it could not figure out what was safe and what was not within this landing ellipse. However, Perseverance has terrain relative navigation, which is a new technology where we actually carry maps on board for the first time on a spacecraft, and it uses those maps in real time as it's landing to figure out where it is as it's coming down onto the surface. So typically on Mars, we know where a spacecraft is within plus or minus 300 meters. Not safe enough to land in a very hazardous area like Jezero. So it takes pictures as it's coming down, and then it matches it up to this map, this visible map, and then it knows where the rover is within 5 meters, which is a huge improvement. And then it needs to decide where on the surface can we land, where is it safe. So also on board is the second map on the right, the hazards map, which shows safe areas to land in blue, as well as hazardous areas in red. Big rocks, high hills, deep sand pits. And so you can see from that little white circle, that's where the rover landed. And if you look really close, it's just a nice little light blue patch of safe area between two big red ones. So terrain relative navigation literally made this mission safe and success for years to come. So again, we take these maps from the engineering world into the science world. We use those elevation models to look at the geology both in 2D and 3D, as well as develop the geologic maps to show where the rocks are most interest to the science team, and can we visit them with the rover, and which rocks would we like to visit and collect samples from. But as you know, in the GIS world, we've gone from our static paper maps to fully interactive web-based maps, and we do the same thing both for our internal science team and engineering teams, as well as for all of you. So you can follow along at our NASA websites and watch the rover progress day to day and see where the helicopter is flown. And we really hope you join us in this adventure because every day is a new view on the planet of Mars. And thank you so much for having me.
Next, I'd like to take a few minutes and describe Esri's geo-enabled systems. These are about supporting with individual products focused workflows for indoors, for urban planning, for landscape planning, for business analysis, and most recently, emergency management and response. I'll start with indoors. This is a GIS for space and building management. It visualizes and analyzes all aspects of a building. It includes tools for being able to do data management about a building, and then organize and manage spaces, operations, and it even includes a series of apps for navigating inside of a building with indoor positioning technology. This is changing the way people see buildings. They're able to manage it more efficiently and more effectively. ArcGIS Urban is a 3D scenario planning system for both cities and regions. It's about geodesign in cities where you bring the data together, you do analytics like suitability analysis, and then interactively do scenario planning and quickly evaluate these alternative scenarios. This is exactly intuitively what you would imagine a city planner should do. Quickly, interactively, and with stakeholder engagement, evaluate technically different alternatives to create a better future. We've been doing lots of new enhancements here. You can glance through this list. My favorite one is to be able to sketch buildings easily into the environment of urban so that I can quickly evaluate them. Similar to urban, the ArcGIS GeoPlanner is about geodesign for landscapes. And it follows a very similar pattern. You bring the data together, you do scenario planning, visualize and analyze the impacts of different landscape plans. Here I'm talking about like designing green infrastructure or being able to achieve the great goals of 30 by 30, saving 30% of the open space by year 2030. And I invite you again to go to these workshops. They're a lot of fun and you'll learn a lot about being able to create a future which is more sustainable. ArcGIS Business Analyst is location-based market analysis and analytics. It comes with a huge library of geographic information and then has many tools for doing things like site suitability analysis, being able to do market research and infographics about geography. It's a huge benefit for businesses like Starbucks and Nike and Walgreens and hundreds of others like it. But it's also innovation and attract businesses to a community. ArcGIS Mission is a command and control system for tactical operations. What that means is like a fire or a search and rescue effort or a disaster response. It likewise brings the data together in a server environment and allows users to plan and execute and then see firsthand situation awareness of what's going on in the field. It consists of a series of applications both for managers of an operation, but also the first responders out in the field who are messaging back with peer-to-peer communication among themselves and with the headquarters office. Very fun technology. Well, some of you are asking what's next for Esri technology. And through the workshops, through the various sessions, you'll be hearing about what we're working on now. As some of you know, we have several thousand people in our R&D and development activities, and they are all very active in these sorts of topics. And they're so anxious not only to support you and please you, but also to hear your feedback about how we're doing in these areas. It helps them a lot, so please speak out and get engaged with them. We continue our incremental releases. This year, we're naming them the ArcGIS 2021 release with a series of dot releases for Pro and Enterprise, and we'll follow that nomenclature going into the future. We're definitely continuously improving our SaaS offerings and actually improving quality and performance in addition to these basic fundamental research efforts. I'd like to close with a couple of comments about the fact that we do more than software. We're all about helping you and develop your own skills, and we do that in a variety of ways. Of course, in real time, providing technical support with hundreds of people around the world that answer your questions and help you do your work better. But also through a large library of books, which we call the Esri Press, with over 150 publications and more coming, with podcasts, with Esri Press, with young professional networks, with well, a variety of resources. I'll just call your attention to the GIS Day coming up in November. It's an opportunity for all of you to participate in sharing your work. We also work on a progressive learning program. This is about building comprehensive skills for you. And we have hundreds of free courses that are available, large MOOCs, a new generation of learning methods called Learn ArcGIS. These are largely free. But we also have structured classes for web instruction, instructor-led courses, and an entire learning plan that I know thousands of you have registered into and stay current with our tools. Esri is all about serving you, and I say that very sincerely. We're advancing GIS and also the science that underpins GIS. We're very committed to strong engineering tools and embrace closely the whole science focus of our engineering efforts. We have an amazing team in this regard. Esri, I'd like to report back to you, is strong and healthy, and it continues to grow. One of our big missions is about promoting geography, if you haven't figured it out, geographic thinking, the geographic approach, and doing so at a global scale. And we like to do this collaboratively with you because I know it supports your work, and it also supports the greater mission of creating a more sustainable world. Esri includes a small team of people who help respond to disasters. This means supporting our users in times of need. And we did a lot of this, of course, in COVID, but in hurricanes and fires, we collaborate with a number of other organizations, including our business partners and volunteer groups like GIS Core and Map Action, to bring resources together effectively to respond to efforts that are affecting our planet and affecting you. Esri also enjoys a very rich partner ecosystem with nearly 3,000 partners, some very large and also many of them smaller organizations that provide consulting services or build on our ecosystem. I'm very proud of them. Normally we'd all get together in a large auditorium section and you could visit with them. We'll be doing some of that live virtually this year. I invite all of you to get connected with these people. They're very powerful and very interesting. Esri also enjoys a series of special relationships. These are largely with NGOs or volunteer organizations. They partner with us and collaborate with us on shared missions and shared visions. Organizations like the National Geographic Society, Jane Goodall's group, the National Audubon Society, E.O. Wilson and their biodiversity work, the Nature Conservancy, and actually thousands others like them. We support them in missions like conservation, which is all about understanding and protecting nature. We provide our software without cost to these organizations. I think they're in the neighborhood of 12,000 groups that are supported by us directly or indirectly. We're also very interested in building the next generation of people, not only GIS professionals, through our programs with higher education, supporting almost 11,000 colleges and universities around the world. We also are looking even further out, building a geographically literate next generation of children. Over 350,000 children have been exposed, played with our tools through ArcGIS Online all around the world. We're partnered closely with the National Geographic Society in carrying this out, helping students everywhere acquire geospatial literacy and develop these kinds of skills that you as a community possess. I invite all of you to become a geo-mentor, adopt a teacher, adopt a school, get involved in this. It's very rich and very rewarding, I promise you. I'd like to close with a couple of final comments. I've shared my sense that our world is a single changing ecosystem. It's increasingly threatened by us, our human activities. We are clearly living beyond our means. To create a more sustainable world, we're going to have to take responsibility for its future, applying our best science, our best technology, and our best creativity. Your work is already demonstrating the power of what GIS and the geographic approach have to offer. You are creating integrated systems that work and support sustainable human activities everywhere around the globe. These are tremendous footprints, actually. Geospatial infrastructure is making our GIS more accessible and scalable. My big vision is that this will expand to reach every organization on the planet, becoming involved, creating a global information system for sustainability, a kind of nervous system for our planet. However, this sustainability challenge requires far more than technology. GIS professionals, and here I'd like to speak personally with you, are going to be essential. You need to provide the leadership, working together, doing all the necessary work, like chopping wood and hauling water. You know what I'm talking about. To apply this geographic approach at scale, this is what will be needed. Integrating geographic science and holistic thinking into virtually everything that humans do going forward, creating a sustainable future. Ladies and gentlemen, our old friend and colleague, E.O. Wilson, had this to say: we only have a short time to decide about our future. We're in a kind of race to save the living environment. And I take that personally, and I want you to as well. Last night, I wrote a few personal messages just for you. First, you're working in the coolest profession, and history will record how very meaningful your work is and has been to changing sustainability on the planet. And I know what you do. I know it's important, and I also see firsthand the power of this work. It's taking everything and put it in context, visioning, seeing the future. I also want to say that I want to encourage you to share your work. I mean, it's very powerful when you do that. Other people learn from you. And this is the only way we're going to get to scale, actually. Share and communicate your work successfully to others, not only within our profession, but also beyond. People are interested. They trust you. They want to collaborate with you. And I'd also say, just personally, build strong professional collaborations. I'm sorry that we're not all together at this conference, because that's the place where we often find a new friend, where we begin the sharing and support network. And I want you, above all, to remember that your work does matter enormously. And also, just a few practical things. Build great maps, maps that tell stories, tell the important stories, because they open the eyes for others to really understand how just very important your work is. So finally, move rapidly. I mean, I love this field. I know you do as well. Move rapidly and urgently, because our world really needs it, because we need to create sustainable solutions, because time is running short. It's late in the day, but it's not dark yet. Okay, so I want to encourage all of you to own this and go with it. Thank you very much. Enjoy the rest of the conference. I'd like to invite you back for tomorrow morning's plenary. We have 4 really great people that are speaking from China about the oceans, about racial equity, about being able to develop a sustainable future in conserving open space and going for 30-30 programs. See you tomorrow.
Så, välkomna tillbaka. Vilken härlig uppvisning vi har fått se nu direkt ifrån USA. Håkan, Annika, Lars, vad är era reflektioner från de här 3,5 timmarna med GIS?
Mitt huvud är ganska fullt, ska jag säga. Men coolaste demot, det går i alla fall till integrationen med spelmotorer, det kan vi säga. Det är jag djupt imponerad av. Sen fanns det ju 100 andra grejer naturligtvis. Jag fick ihop nästan en halv bok med anteckningar.
Härligt. Annika?
Jag tycker ju då det här med det som finns där ute. Så var en rover på Mars. Det är ju jättehäftigt att kunna kartera det som finns långt där ute bortanför oss.
Och Lars?
Ja, jag hoppas att se mycket teknologi för den här digitaliseringsvågen som jag ser ute hos många av våra kunder, hos alla våra kunder. Och det såg jag. Det finns teknologi för allt, precis allt egentligen. Och då blir det ju en fråga om hur man applicerar teknologi, tänker jag. Och det är ju ett bra läge. Teknologistacken finns där, så det är bara upp till oss. Och så det känns bra, tycker jag.
Härligt. Själv tyckte jag att dels när man presenterade GeoBIM som en produkt, det här mötet mellan Autodesks värld och Esris värld för anläggningsindustrin, konstruktionsindustrin, teknikkonsulterna. Och så är jag själv ett stort fan av storytelling och hela den biten, och tycker alltid det är spännande att se vad som händer där. Vad är något mer som ni såg, som ni lade märke till? Håkan tar fram sin stora bok här nu och bläddrar fram.
Jag har många punkter, men om man utifrån produkterna, en stor grej tror jag det kommer att bli det här med image i ArcGIS Online, som gör alla de här verktygen som har funnits i ganska många år i olika desktop-produkter blir tillgängliga för alla på ett helt annat sätt.
Vad innebär det egentligen?
Det innebär i praktiken att du istället för att du har egen hårdvara, egen mjukvara på din egen dator med ganska stora diskar med väldigt hög kapacitet, videokort, allt det här som man behöver när man håller på med bilder, så laddar man egentligen bara upp sina bilder i ArcGIS online och så får man tillgång till ett helt funktionsbibliotek för att göra alla olika typer av analyser eller karteringar eller utdataprodukter. Allt ifrån enkel bildbehandling till AI-analyser som vi såg i de här demorna. Och det är det första jag ska ta och titta på när jag kommer tillbaka till kontoret.
Så det vi såg därifrån Granada, det var alltså, var det bara ortofoton? Det
var egentligen bara ortofoton som man hade laddat upp i ArcGIS online, och sen har man tillgång till hela funktionsbiblioteket för egentligen all typ av rasteranalys direkt i ArcGIS online. Utan att man behöver någon speciell dator för att bearbeta, utan all kraft finns ju i molnet. Så det tror jag kommer att bli ett genombrott för många som håller på med någon typ av raster eller cellbaserad analys. Vilket jag tror ganska många gör. Eller skulle vilja göra kanske.
Ja, kraftfullt.
Det tror jag kommer vara en förenkling.
Ja.
Och sen om vi pratar om produkt- och teknikdelarna framgent, så tror jag att det här med ArcGIS Enterprise på Kubernetes för stora installationer, där vi vet att, som de berättade Filip och hans kollega, att det är väldigt svårt eller utmanande att vidmakthålla stora installationer för många användare och göra uppdateringar och hålla det vid liv och övervaka det. Det kommer att förenklas betydligt framgent när man går över till att köra Enterprise på Kubernetes.
Men Kubernetes är inte för alla?
Kubernetes är ju egentligen att betrakta som ett nytt operativsystem. Där man bryter ner en mjukvara som ArcGIS Enterprise i mikrotjänster. För att det ska kunna skala och för att det ska kunna byta versioner på programvara i steg, som de också visar i sin demonstration. Så det är ju främst för större installationer. Eller för installationer med väldigt hög belastning. Som vi har sett tidigare i år och förra året, om vi pratar om de här alla dashboards som har funnits med pandemin till exempel. Om man har den typen av applikationer som behöver elastisk kapacitet. Både uppåt och neråt. Så att säga, och kunna, utan att man behöver laborera med egen hårdvara. Som är en utmaning för de flesta. Så det tror jag kommer att ha påverkan framåt.
Bra.
Själv då?
Ja, men jag tyckte ju som sagt att det här med GeoBIM är väldigt intressant. Vad det kan innebära. För att då har vi det här samarbetet mellan Esri, mellan Autodesk, och där man då kan ta ett samlat grepp om hela arbetsflödet. Från det att man samlar in underlagsmaterial för att projektera någonting nytt. Får det på samma plats som där man börjar bygga konstruktionsritningar och arbeta kollaborativt kring det här. Och jag tror att vi kommer se, framförallt hos våra teknikkonsulter, tids- och effektivitetsvinster, men framförallt kvalitetshöjande åtgärder därigenom. Det tycker jag verkar väldigt spännande.
Och även för samverkan. För det betyder att du kan ju samverka från en första konsekvensutredning till förvaltning utav ett byggt objekt i en och samma sammanhängande integrerade miljö mellan oss och mellan Autodesk. Så jag tror precis som du, det där kommer få en jättestor betydelse framgent. Och speciellt när det gäller effektivitet och samverkan, kvalitet och de sakerna.
Det är ju samma sak med drönarteknologin också egentligen, att det händer där. Annika, vi pratade lite om det här med att hålla sig ajour, utbildning, att hela tiden lära sig nytt. Hur ska man hantera alla de här nyheterna?
Ja, alltså det är ju jättemycket. Och det har vi har hört om de här 3,5 timmen som det har gått. Men dels så finns det ju väldigt mycket att tillgå online. Att gå kortare kurser som tar några timmar. Självstudier, jättebra. Vi håller ju utbildningar online. Kanske någon gång framåt när vi inte är i en corona-pandemisituation så kommer vi kunna vara tillsammans eller vara ute hos våra kunder återigen och göra workshops och sånt som är mer fokuserade då i olika delar. För jag tror mycket är det här att det är så stort idag. Så det är inte så att du går in och lär dig en stor del av det här. Utan du kommer liksom behöva utbilda dig den delen du jobbar i plattformen. I kombination med att det här är då kopplat till andra verksamhetssystem. Så det är ju inte, GIS är inte en ö för sig längre, utan GISet är ju en så stor integration i hela företagets eller verksamhetens organisation och verktyg och användande dagligen.
Och jag tänker Lars, det ser ju du när du träffar många av våra stora kunder hur viktigt GIS har blivit affärskritiskt.
Tänk på vad du, om jag bara kommenterar det du sa, Annika. Att, jag tror man behöver kunna lite grann om mycket när vi pratar om digitalisering överhuvudtaget. Så jag tror det är jätteviktigt att fatta så man vet vilken teknologi man ska dyka ner i. Och det är likadant med geografi och GIS nu. För den sitter som en del i en enterprise stack för all digitalisering. Geofy everything. Alltså geo-AI, vad står vi med? Geo-journalism pratar de om. och så här saker. Som geofy everything. Och man behöver inte kunna allting, men man behöver kunna så pass lite grann om det mesta som man begriper vilken del av teknologistacken man kan använda, bruka för ett specifikt problem till exempel. Och sen så kan man vända sig till oss eller våra partners och hitta experten för det. Och sen avslutningsvis för min egen del, när jag tittar på det här som han brukar kalla för your work, Jack när han presenterar på alla de här andra konferenserna, då visar han exempel från alla branscher och även horisontella områden, liksom lösningsområden. Och vad är det? Är det 100 exempel? Räcker det?
Ja, det är nog mer.
När man liksom kikar igenom det här och tänker man så här, herregud, man kan använda den här teknologin på alla möjliga, överallt. Det är fantastiskt. Så jag tror inte det är, jag tror vi har kvar att göra faktiskt, tänker jag.
Verkligen.
Också det.
Absolut.
Och kul att se Uppsala på den listan också.
Ja, jag har redan lagt under på LinkedIn.
Ja,
det är kul. Bra där.
Ja, men det är väl härligt det. Ja, precis. Men som en del av det här med utbildning då, Lars, kan man ju säga att våra egna svenska användardagar i höst är ju ett sätt att utbilda sig, att få en, kan man säga, en komprimerad version av hela UC, där vi någonstans då berättar vad som har hänt, vad som är nytt och vad som kommer.
Ja.
Vad kan vi säga om det i år? Hur kommer det se ut?
Vi håller tummarna och hoppas att vi kan göra det här in real life. I oktober så är vi i Malmö, Göteborg, Stockholm och Luleå. Och sista stoppet är Stockholm och det sänder vi också live.
Just det.
I vilket fall som helst så sänder vi det live. Så det finns möjlighet att se det.
Och där finns det ju mer information på vår hemsida, esri.se. Om anmälan som också är kostnadsfri därigenom. Jag tänkte att innan vi avslutar för idag så vill jag gärna slå ett slag för någonting som ligger väldigt varmt om mitt hjärta och även ditt, Annika, och Lars också, tror jag. Jag vet inte hur det är med dig, Håkan, men...
Ja, vi får se. Det beror på vad du menar.
Vad pratar du om nu? Ja.
Under UC så finns det en liten kul tävling, lek, vad ska vi kalla det för? UC Fun Run. Ja, precis. Vad är det för någonting?
Jo, då kan vi återigen, nu är det sport igen, min hemmaplan. Det är alltså en tävling som går nu, eller tävling.
Det är till för alla.
Till för alla. Som pågår från igår söndag till på söndag. Där du kan, hur många gånger du vill, hur långt du vill, så kan du kan springa, du kan cykla, du kan gå. Jag såg någon som hade varit ute och ridit. Jag köpte en ny supp, så jag tänkte jag skulle ut och suppa. Och så tanken är ju att vi ska försöka gemensamt ta oss runt jorden.
Yeah.
Så anmäl er på Esris hemsida på UC-sidan. Och så laddar man ner en app som heter Quick Capture. Så kommer man igång med det här.
Och så kan man se resultaten sen i en snygg 3D-applikation också. Med sina foton som man delar med sig av. Väldigt snyggt och geofierat där inne.
Ja, vad härligt.
Och Lars, man kan cykla också. Som
ja, det ska jag göra.
Ja, jättehärligt.
Får man åka motorcykel?
Du kan säkert. Om du springer bredvid.
Det var inte för dig det här då, Håkan?
Nej, det var inte för mig.
Nej, men du spelar ju badminton ibland. Du kan ju se om det blir något.
Fästa telefonen på badminton.
Kan bli det.
Ja, kanske det. Nåja. Nu om ett litet tag så börjar sessionerna för ikväll. Om ni orkar. Annars så får ni fortsätta imorgon med att logga in på UC-sidan. Titta på de förinspelade sessionerna. Titta på det som har varit nu då ikväll. Men jag rekommenderar att ni är med i den här Q&A-sessionerna och lyssnar in, pratar, delger era tankar. Gå också in på den delen som kallas för Expo, där ni kan möta våra partners, titta på deras sessioner, prata, diskutera lösningar med dem och även lyssna på använda presentationer. Vad har vi mer för någonting? Kartgalleriet är att förglömma också. Men som sagt, 21.30 svensk tid så börjar dagens live-sessioner. Några andra sista ord?
Nej. Det finns teknik.
Ja.
Det är inte problemet, nej.
Applicera den på ett klokt sätt.
Precis. Och vad sa Jack? Make great maps. Det är ditt ansvar att göra det. Hörrni, stort tack för att ni tittade. På återseende. Hej då!
Hej då!